Boop, boop, boop. Let's see. Pop out chat. Pop. Go. Gotta make some space. We got a day of building ahead of us. How are the cameras doing? I just booted up OBS, so they're gonna be in a state. Oh, that's pleasant. What's going on back there? Let's see. Do the face procedure. Are we back? We're back. Okay. Here we go. I think I'm due for a beard trim. I think I need to do the beard and the hair. I got to do my medical application though for assistance. So that's going to take precedent over anything else. We got VCOs to, oh, this is rather loud. Hold on. There we go. Sorry about that. You guys can't hear me. I wouldn't be able to hear a thing. Why was the desktop audio so loud? Weird. Well, that's a Twitch problem. YouTube cannot hear any music right now. You could look it up. Credit where it's due. I think it should be like behind my head. That's actually pretty good. That's pretty good. Me in the corner. That's me in the corner. In the spotlight. There's literally a spotlight right there. Let's see. Nothing going on since last stream. Nobody tried to sneak in anything. I'm still using Streamlabs. I told Twisted Sister that I'd switch off of it, and I never did. I never did. Oh, we need to get the prints started like now. So let's get the front panels ready to print. There's an update. I'm not going to update right now. I'll update once we start working on other stuff. We got a lot of soldering to do today. So I want the front panels. That's not the front panel. That's going to be my update on the RC car thing when stream starts. Then what am I looking for? There's something new about the way projects are categorized, and I need to look into it. We are in mod synth projects, and these would be the RP2040 VCO, and then I need both front panel. So 6 VU chords, and then where's the other one? Oh, I guess I added the circuit to it. What's going on with this one? Oh, I need to repeat those steps. I don't know if I have the potentiometers to do this. I might need to order a bunch of alpha, or the alpha knockoffs, whatever the hell I'm using. What are these called? Show me in the tree. These are called Alps. I may need to order some Alps 10K pots on like super duper rush delivery. We'll figure that out when we get there. I think I've got a couple left, but I'm gonna need more of those. I'm gonna need more RP2040s if this works. Our first task is to get this thing to work under any circumstance. So let's get the panels themselves printed. So that would be the bodies, and then this RP2040 saved as a mesh. Okay, save it. Yes, replace it. And then the chord VCO, I need to bring to current day. All the holes are there except for, nope, all the holes are there. Wait, where's the LED? Where's the LED? Where is it? I don't have the LED in here yet. Okay, so we got to do that. Here, why don't you guys come over here? No, it's a so we're following here. I gotta open up the web page, and this is like the stream hasn't quite started yet. Let's just do start soon. Yeah, Eurorack. It's Eurorack, correct. Hagiwo makes a bunch of these really cheap, and I don't mean like cheap as in like bad quality. I mean cheap like they're not expensive to build designs for Eurorack, and he made a chord VCO and a regular VCO that uses an RP2040 as like a basically an audio driver. So, oh, what is this? This is a Venetian snares. Hold on, let's go back to this one. Sorry, dealing with music over there. Okay, so Hagiwo, credit where credit is due. What we did is we took a circuit and we turned it into our own sketches. That's the outline sketch. Wait, oh, this is the wrong sketches. Sketches. I should have made these boards 100 millimeters though. That would have saved me quite a bit of money. 100 by, and then I guess it goes off of this rail. 100 by 4. And that's off of the PCB. So when I go into sketches, I want the sketch with the PCB outline. And so there's the bottom corner of the PCB, and we're going 100 by 4 with a construction line. 4 by 100. And then I'm doing a, I think it's a smooth fit hole. So we'll do a 3 millimeter hole. Let's make it 3.2. I'll check to see what the other one has. Yeah, 3.2. So that 3.2 is the LED will fall out of the hole, which is what we want because the LED is going to be mounted to the PCB, not that hole. So I'm going to finish that sketch, and then I'm going to go into my holes layer, my holes extrusion step, and I'm going to re-highlight this guy right there, and now we have an LED hole. No labels yet, no labels yet. Save that mesh. Okay, I think my blood pressure is super high today. I can like feel it in my neck. I feel like tightness in my neck. Interested in modular MIDI controllers in a similar form factor as a fun project. I know Speedy Cat, who may show up in the chat later whenever we do synthesizer stuff. I see Speedy Cat hanging out. He's been doing an SPDT switch based MIDI controller. I think MIDI controller. It might just be a sequencer, but pretty cool project. Wait a second, what happened here? Hold on a minute, I spot something. Just 1 second here. Where are my holes at? Why am I missing holes? It wants the latest circuit, but I don't really care about that right now. What I'm looking for is where the hell my holes have gone. What have you done with my holes? They're... hello? Why aren't they here? Why aren't they in the sketch? What? Huh? What did huh? What the heck? Okay, all right. Well, that's easy enough to remedy. I just need to go to, probably just look at the PCB and use the measure tool. The measure tool doesn't get really, oh yeah, it does get me to the center, but I don't have an edge over here that I can go off of. Damn it. Well, I can just measure the X and the Y separately. All right, so we'll do from this point to, hold on, control. Hold on, show me these things. Look at all those points. To the center. Is that the, well, that's the center of the hole that I need to make in the PCB. So, and then go to XYZ. So we are three and a half. Why is it always the hard to read? 3.5, 8.5. Go to the sketch, 3.5, 8.5. Yeah, where did my bottom row of holes go? So there's our 8.5. So let's do a 3.5 here. Construction line. And then we do another one of these, which is 6.4. But 3.5 seems a little low. That doesn't actually seem correct. Let's double check. It's definitely wrong. I'm trying to do this quickly because I want to get this started to print. Plan is a simple Pi 0 as a master, some kind of bus, SMT32F03. All of those are way overpowered for what you're doing. You can do MIDI inside of a PIC microcontroller. So yeah, those are good choices because you'll be able to develop for them very easily. It's all about that ease of development. It's 11 millimeters. Okay, that makes more sense. Oops, we're still in the same drawing. 11 millimeters. Sorry, I'm a little frantic here because I thought this was done. And then basically we have another line off of this. It would be another 8.5 from the other side, I guess. So it ought to be 17 from this one, or 17 from the edge. Why do I keep going back to this? Well, because those are both supposed to be the same thing. So if I go and finish the sketch, and then we measure from center to center on these two, center to center, 13 millimeters. So this would be 13, 14, 15, 16, 17, 8, 9, 10, 11, 21 millimeter, 21.5. That wasn't the number I thought it would be. Well, supposedly it's 8.5 from this side. Let's give that a shot. Well, or I could just do this. I hate to base the numbers on other numbers in case you need to kind of wiggle stuff into place. We had pretty good luck with these before, but I mean, that looks pretty close. God, all the area highlighting is very annoying. Oh, we're full screen. I need to come out of full screen. What's up, Jojodi Yodo? Did I say that right? Yodo? Is that YOLO? Sorry. My brain like substitutes things in. Here, I didn't have chat in front of me because this wasn't the right size. In sort of the craziness of hosting a stream, the brain goes in all kinds of different directions. We'll get a little bit more professional as time goes on. Can you believe that Rooster Teeth shut down? I can believe it. It's just end of an era. 6.4. Every single like person associated with Rooster Teeth over the past umpteen million years has started to be like tweeting about it. Yep, those do line up. Okay, so it's 8.5, 13, 8.5 in order to line those things up, and it looks like my circles are right on the money for the design. So let's go ahead and get out of the appearance menu, finish that, and let's go into the step that makes the holes. That's that one, and then just boop, boop, boop. So that should be everybody represented, including the button over there, the two switches, the potentiometers, and the LED. So now we're ready to export that one. That was a little bit of a rushed thing right there. If I was working alone, that's basically the pace that I go. But when I'm educating, when I'm teaching you guys how to do stuff, I tend to slow down a little bit and explain myself and not be a complete motor mouth as I go. It's just, I wanted to get these things printing right away so that we have them when we're done building the circuit. These are modular synthesizer racks. And they are voltage controlled oscillators. So they are designed to make music notes given the voltage that they receive. Not laser cooler. What's that doing there? There you go. VCO apple for... I don't need no apples. I'm diabetic as hell. Nope. I should print these in dark red. That way I can give Julian one of them. Yeah, we're going to print these with the color that I already have loaded up into the synthesizer. Or sorry, into the 3D printer. New PC config. What, huh? What I actually need to do is I need to go into the tools, the Stream Deck tools, and I need to find the window arranger and use that, because I have a very particular arrangement of windows that I use now for streaming. Like social stream is here, but my moderation view are here, and the YouTube comments are here, and that's what these two feed that social stream blade. But then over here, I always have music, and then next to it, I have Streamlabs so that I can keep track. For instance, Wayne Johnson's comment was actually a subscription. So thank you for the 46 months, Wayne Johnson. I really do appreciate what you're doing. I love you for this. I do. Thank you for the apple, but take it back. Go plant a garden with it. And then, yeah, here I've got the actual, what do you call it? The window where I'd moderate your asses. Like, for instance, deleting comments from Journey Started. There we go. Get fucked. All right, so anyway, yeah, I do light mode because I've got a spotlight in my face. Listen, when your pupils are already completely contracted and they're pinholes, you use light mode. Jajoda YOLO, thank you for the Prime sub with a tier 1. And the Hype Train, heck yeah. All right, printer. Camera's not configured. Hold on. Properties. Configure video. I need to put a light over there. I've got plenty of lights. I just need to put one over there. All of these wonderfully easy tasks that are like poison to an ADHD person that I just need to do. All right, let's get the printer started up. And I should make a little box for this sign so I can put LEDs behind it and have it do like a fun little LED thing, because I've got all the parts. I did it for the rack, and then I could just put a microcontroller on it and have it do fun little patterns. Do you have a good way of getting 3D models of parts for Fusion besides the built-in ways? Oh yes, absolutely, Jojo. Here, the best way that I have, aside from like certain parts, the manufacturer will give you actually a very comprehensive 3D model these days. Some, I said you have an impressive monitor arrangement. In somehow banned words. Journey, read the room. I said, this is the screen where I moderate and delete comments like this one. And then I deleted your comment. That was literally the only context under which I did it. Just purely by the fact that I was explaining what that window was for and your comment was right there and it would be funny. You did not do anything wrong. So to get parts for 3D printing and design and stuff like that, I have found a couple ways. Now, one of them is if the manufacturer has listed their part. This happens a lot with electronics. They will have an incredibly detailed model that you can use in your software. And you bring that model into Fusion, and then you put all the right material colors on it, and then you have to build a part around that for electronics design, or you can just drag and drop that into your parts. So I have lots of parts that I've reverse engineered, but also in Fusion, I have a lot of parts that I've pulled in from the manufacturer. For instance, like like Alpha Cool radiators is one of the ones that I use a lot. Alpha Cool has an extensive 3D model section on their website. But then if you do need external parts, there are, this is the wrong monitor, I don't know why I clicked that. There are websites, and one of the websites that I really like is GrabCAD. GrabCAD is an additive manufacturing industrial setup. They bought the original GrabCAD and they redesigned it, they retooled it, which is okay because they have just an amazing library. So if you go into Community, you can click on the Library tab, and then you have this incredibly extensive and varied just listing of 3D models. So if I need, for instance, like an SPDT switch, there are a lot of different varieties of switches on here. And so you can pull one into your own design. You just need an account, and you can tip the person who makes a design that you like particularly well. So let's see, I turned on the 3D print. I need to go to Octoprint. So that, I mean, that's one of the ways that I scrounge up for parts to build things. One of the primary ways, to be honest. Clipper standby. Let's reboot the firmware and see if that brings it back. I'm listening to see if it clicks. Oops. Do we get clicking noises? It says it's ready. I'm gonna try to put the PL touch down. Ooh, I heard it. Okay, so printer's ready to go. So now I'm going to go to Super Slicer, slice it, and then print that up. I got two different versions of Super Slicer, it seems. The one at the desk is slightly different. Oh, is there? Wait a minute. Damn it. I need to stop this print. That's going to take forever. Yeah, it's all about knowing those little websites to go to. Cancel the print. Now we got to wait until it does the entire warm-up procedure, unfortunately. So this is gonna take a little bit. I guess we got time, but still. No supports. It's gonna be like it's an hour print. That's actually a legit amount of time. The more, what's up, Slime Swaller? The more, wait, what the hell? My two chats are out of sync. Oh no, they're there. The more stuff I have on the bed, the longer it takes, because my first layer with PETG is extraordinarily slow. extraordinarily slow. I'm gonna change it up here, find some other music. Finding music. It keeps playing the same song. Stop it. Get me out of here. Let's go somewhere down here. I don't know, maybe not C6 Steve. Something a little weirder. Deadly premonition music. There we go. A little bit more appropriate. I need to clean out all those bins. They're starting to get really disorganized. Like, the longer I put it off, the worse it gets. You just go over there, sit on the floor, and just go through it all. There's potentially a lot of storage space that I could glean off of getting old projects out of the way. It's been a while since you fell. Are you all better? Man, you know, I got a thing. Like, when it starts to rain, we've had nothing but rain here because I kind of pseudo finished the RC car in the background. I finished the RC car. I still have to tune it, which is why, having finished this, I think I caused our recent rains. So it's been raining for a week, right? And so I get, in this area right here, I get tightness, and then sometimes I get like raspy breath. It's a very strange feeling. It feels like fluids filling something. I'm totally fine right now. I'm completely 100% fine. The skeleton's a little bit sore, but nothing terrible. But then every now and then it's just, and I just kind of like take deep breaths, and I'm still getting air, so it's not that big of a deal, but it's a weird thing. I don't know what it is. I think it's maybe like swelling or fluid buildup or something related to having vaulted myself down a flight of stairs months and months ago. But really, I'm okay. I'm really just fine. Everything's healed up just fine. I need to lose weight. That's for goddamn sure. Efforts are being undertaken slowly, as not to burn myself out on it. And the main thing that I'm doing right now is uploading videos. But yeah, I need to put together my financials too. That's a big stressor right now. And then we had some other family stuff going on medically, and it's not over, but it is a lot less of a thing than we thought it would be. So there's a lot of relief in the background of the stream here that I don't really want to go into. I don't really want to go into. Weight is overrated. It is rated over what I should be. Yes, correct. Yes, indeed. Yes. So many projects, too many projects, in fact, but we'll get through it as we normally do, just one day at a time. Next build, treadmill driving an electric generator. I was going to, and I still have, here, if I go over to the 3D printer, I can show you. Oh,
yes,
1 sec.
It's all right. I'm here.
Hold on 1 sec. Hold on, I gotta deal with something. Sorry. Oh, sorry. I explained everything and I was muted. I was muted. You didn't hear any of that. I had a family member who came down and told me that they were on the phone with Microsoft and that our IP had been compromised, which is a pretty ridiculous claim. Apparently something pulled up a screen on the computer and it was glitchy and it said, there's a problem, call Microsoft. And so they were running all kinds of scans on the computer. When I caught this and I had to get them to stop doing this because it was a clear, it's a Kitboga scam, right? You guys know Kitboga. It was a very blatant Kitboga scam. And so I got everything under control. It's just I don't know what they've accessed at this point because they got all those scripts. Well, I wish I had gotten wind of it before the phone call. Spray bottle, no, please. I don't want to get into that. I'm already shaking mad right now. I'm shaking mad. I'm actually like shaking because it took a lot of convincing in order to get that to shut down. So I'm going to go look at the computer. What is the user account control that does startup programs? I know there's a like user account control that I need to get into that does startup programs because I think what is it called? The connection program that they used is on that. I need to get it out of the startup. Any handy Windows 8 people here? I'll figure it out. I'll look it up. Because I got to make sure that any of the stuff that they're doing is pretty much like shut off. Because they had script access to the computer, so they could have run just about anything. So you guys watch some printing. I'm gonna put the music back on, I guess. I don't know how long this playlist goes for. But I need to, here, let me put text up on the screen. Create new hack. Yeah, sorry everyone, you guys get BRB partied for now. All right, I will be back as soon as I can. Fear not, be not afraid. Is there like a 4-hour mix down here? I think there's some long mixes way down here. Evil 9, 16 minutes. I had to make a basic plea for humanity that I know what I'm talking about and to actually listen to me, but I never get listened to. Never. Let's just do like we'll do one of these. Do SoundCloud Space Cowboys. For the Twitch viewers. Nobody else gets to listen to this. Let's see. All right, I'll be back as soon as I can. There's never any chill, is there? There's never any chill. Apparently they entered banking details, so now they have to go through all the bank account stuff and see what happened. I'm just annoyed that I had to make an emotional plea in order to get that shut down. Let's see. I need to stop the print. That's what I'm looking for, my Octoprint window. Let's just pause this. I think there's nothing in my control that I can do anymore. I looked through to see if any shady software was running, and it didn't look like there was anything. And I ran a Windows virus scan, and it didn't find anything. So I don't know what other, I haven't watched Kitboga lately. I don't know what they're doing, how they do that stuff these days. But they were definitely running the fake scan scripts on the computer when I got to it. And they had IP access through one of those User Connect programs, one of those easy to use ones. So they had full access to the computer, and they were running stuff in console commands. Josh from Microsoft, who had a thick Indian accent and had all kinds of buzzing noise on the phone, there was an excuse for that, because they said that your stuff has been hacked, so your phone's going to sound funny. And it's like, oh no. Yeah, they got good, which a lot of people do get got good. I just thought people here had a little bit more sense than that. But here we are. My mood has been completely destroyed. It has been blown up by foreign computer hacking efforts. Why is that peeling up in this area? That should not be happening. Looks like it got all gross right there. What a bunch of piss. So mad. We had a call earlier today with Verizon. I think maybe that's what triggered it. I don't know how they're getting access to like phone logs and stuff, but we are upgrading all our Verizon stuff, so I don't know if that triggered something to do this stupid hack. I just hope it doesn't happen again. The family member knows that Microsoft will never do this now, but it was like to the T, like the exact script, and I kept getting assured that that wasn't what was going on. But yeah, it definitely was. How do you talk them down off of the ledge when they've got some other computer, some other person scanning their whole computer? It's like Microsoft doesn't do that. They don't do that. Here I am, the voice of reason, and I'm being called a fucking like terrorist because I'm familiar with these things and I know how to shut them down immediately. The guy even had the audacity to call back, and I was like, never call this number again. Like, I will find you. I'll get a big plane ticket. It's worse than that. What they do is something runs on your computer, probably through there was a Microsoft Edge browser was completely flattened when I opened it up again. So probably through Microsoft Edge, some exploit that Microsoft is too dumb or ignorant to cut off. They basically put a full screen thing on your browser that has the Microsoft logo, and it says your computer has been compromised, and then it puts these little glitches all over the place, and it says call Microsoft service, and the number for that is a Google phone number. And then they have all of these like sort of passable to somebody who doesn't know cybersecurity excuses for why they are legitimate, and they give you those excuses, and then they get you to, in like, not TeamViewer, what was the program called again? I uninstalled it like almost immediately, but it's one of those let somebody else use your computer programs. It's the exact script of Kitboga. This is exactly what goes on his stream. That they shut down stuff like this with regularity because, yeah, it follows all these steps. And so you get somebody, who assures you that they're definitely from Microsoft and that you should log into your bank accounts on your own without their help. No, it wasn't Log Me In. It was one of the other ones. Let me take a look here. I'm still shaking. I don't need a stupid. Rust, TeamView.o, Screen Connect, /stop, AnyDesk. I don't think AnyDesk. TeamViewer, yeah, my buddy got TeamViewer hacked at one point. TeamViewer decided to cut off India. That's what my friend tried to do with his credit cards, because he got TeamViewer hacked, and he called the credit card company, and he was like, listen, I'm not going to buy stuff from India. I'm not going to go to India. I would like you to cut them off. And he's like, and China too. And I'm like, all right. I can't do that. I buy stuff from China all the time. But he wanted to cut those regions off. And he's like, I know you're able to do it. I know you have the software to do this, because I used to work for you guys. But they were incredulous. They were like, why would you do that? We can't do that. Chrome remote desktop. No, that wasn't it. It was a particular, it might have been Screen Connect. Remote PC /top, real VNC. I just need a list of them. I don't need, I forget what it was called because I'm so worked up. Was it AnyDesk? And no, I don't think so. I don't know. I uninstalled that shit with wanton abandon, but I still feel like I need to go through the registry and look for stuff that they might have done. I don't know if there's a guide to unscrewing up a PC. Remote desktop software on, run a few random commands to make it look like they're doing something, but they don't do much in the system itself other than steal files. The real goal is to get the person to log onto the bank and run the refund scam. Remove any desktop software, turn back on any firewall software that may have been disabled, which I think I did. I'm not sure if I did that. Check that there are no system passwords have been changed. I think we're good on that one. I'm not totally sure. Yeah, 2FA should be... we're sniffing hacked fumes right now. Change all your passwords to banking, email, etc. to prevent their use and misuse. That's going to be first and foremost. Do it from a separate system. Well, consult your old system's saved passwords to remind you which accounts and services require resetting passwords. Yeah, it was a computer upstairs, family computer. We ran antivirus. We're definitely not dealing with pros, but she did log into banking accounts. But the bank accounts weren't saved. I saw New York Times password was saved, and that was, I think, it. Look for an added user account. Okay, let me go do that. I'm going to start this print here. And let's put up a BRB. Where's BRB? Yeah, so I guess what am I going to do? I'm going to go up there. I'm going to look at the firewall. The firewall was enabled. At least one of them. And then the other one is user accounts. So, all right. And then the refund scam? What is that about? Run the refund scan. Live CD to pull important data. Because you said it's the virus scan, not the refund scan. The most important thing is to check the history on Google Chrome. You might have deleted it, but if not, it's very important. What Kit's video don't show is that if you actually pay, they tell you to leave the computer for a few hours. Well, it's the different opposite scam. They can use your computer to try to get your email, and then use that email to create accounts on certain websites to help them launder money. Okay, so what's the refund scan? System restore. I got a call from Microsoft. No, they have you call. From Microsoft, PC error reports. Yeah, this is unfortunate. Remote access was given. What should be done to prevent it? It's a scam. Microsoft doesn't call people because of the errors in the computers, and this is the big thing that I had to fight. To quote Admiral, that was really unnecessary. Could you please get this out of your article? That's so stupid. Lots of reports of scamming, its variants, for blah, 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 blah. The scam, simple, someone calls you claiming to be from Microsoft. Anti-malware provider, some other authoritative company. Of course, they're not. ISP claim to be. Yeah, they claim to be from the ISP. Oh, man. I wish I had seen this earlier and been able to shut this down. Problem with your account, blah, blah, blah. To prove there's something wrong, they ask if your computer's been crashing recently. Or they have you open up the event viewer, point out that many, many errors listed there. A little different, this one started with the browser doing something to the screen. Log me in. This one wasn't log me in, but still. Scammer installs malware. The scammer discovers that in order to fix your non-existent problems, you need to purchase something. You're quoted a high price. It's not quite the scam that we were getting. Event viewer. Yeah, event viewer is a mess. Assume the worst. Hope for the best. This is the least helpful article I've ever read. This is a terrible contribution. Can I get like, jeez, this is useless. Fire scam, not the refund scam. He did release a video about general internet privacy. System restore, and that's pretty much it, huh? One expert advises. That was not advice. It's practically an AI article. This is essentially what I did. I didn't reboot to safe mode. I just simply rebooted and then I shut down whatever the share program was. Turn off the router, turn off the Wi-Fi, blah, 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 blah. Yeah, safe mode still exists. It's very useful. Sort of useful. It's sometimes, in one case, today, it probably would have been useful. Other than that, I don't think I've used it in a long time. Rolling back to a previous save point is suggested again. I wonder how many save points exist on this machine. Change the local profile to a non-admin. Ugh. We might need to get this person a new computer. Keep the internet disconnected while you remove whatever software they got you to download. It's much like downloading a virus. As long as you don't run the thing, you're safe. That's pretty much where I am right now with this. As long as you kick them off and make sure to remove what they'll use to reconnect to your device. And I didn't find any weird stuff running, but Windows 10 has a lot of weird stuff running and that I wasn't able to identify quickly because they're now going into the bank accounts to make sure everything's okay. So... And from what I saw, they were running like Microsoft-based scans. They were getting to that second part of the scam, but I don't know what else they might have gotten there. I hope everything's okay. I'm gonna go up and check on the status and see what's going on, and I will BRB. In the meantime, I'm going to start this print again, and hopefully it doesn't get all cattywampus on us. And I'm gonna print the new print. My brain is going in 6 directions at once right now. It's fun. All right, that's going to do its thing. I'm gonna do my thing. I'll be back in a second, and I'll put this back on. Oh my God, I'm back. There are no active signs of anything happening to the computer, but it was definitely the virus scam, and they did not get to the end of the scanning part of the scam, but that doesn't mean they could have run any type of script on the computer. I was alerted to this right at the beginning of stream. I had a notepad held up that said, our IP has been hacked, and it's been completely compromised. And already that's stinking of that kind of language, of the scam language. So I go upstairs, and they're on the phone with a fuzzy phone call with somebody with a heavy accent, heavy Indian accent. I don't mean to judge, but why is that always the case? Heavy accent, and they had access to the computer, and they were running all kinds of command prompt scans. And the telling thing about the command prompt scans, how did it get infected? They pulled up it. So, okay, first of all, Facebook. Chrome history shows a very big Facebook URL. There was a dog in a contest that we know that they are, voting for daily, and there's probably a shady website, like a shady advertisement link, I could guess. Oh yes, BrinkGG, if you want to send me that checklist, I would absolutely love it, because I am new to this, and I never really learned anything about it, because I'm not the type that gets hooked, but we got hooked, and I'm nervous about what I don't know to get into. So having a list of stuff would be very, very useful. You're on Discord, right? I mean, getting that through Discord would be ideal. I can always like PM you my email if I need to. Maybe give you my credentials, my account credentials, and then maybe call you and give you like log me in access to all of my computers so that you can fix it, right? Right? Anyway, nearing 10 years of IT veteranship. Thank you. No, I actually, Brink, that's amazing. That's actually very amazing. I am humbled. Can you share the checklist here or the Discord? Yeah, whatever you feel is necessary. Don't go out of your way. Sometimes they're kidnapped, and I haven't watched a lot of Kitboga. That sounds terrible. I know that like living conditions can be completely terrible over there, and jeez. But like, okay, so the thing is, what it is, first of all, it was, dog website. They're not vetting out their ads very much. So I don't know if somebody clicked on a part of the page they shouldn't have, and it pulled something up in the background. It gave, there was a big shady Facebook link that I'm not sure if that was that website's way of logging into their own Facebook page, or if that is what took over, because Facebook asked for a login. And so that's what got that. So the Facebook instantly compromised. Some kind of a thing opened up in Edge. It was an Edge window that had been completely collapsed, and that thing that opened in Edge, hold on, I gotta like pause that over there. The thing that opened in Edge more than likely put up a big Microsoft logo, big Microsoft logo, color graphics, and all kinds of stuff going on, and glitches. And it said your IP has been hacked, it's been compromised, your phone system may suffer from this, which the phone system is completely different from the internet. So there's no way that would be the case. What they were doing is making an excuse for their terrible phone network. And so I go upstairs to don't acknowledge this is a scam. Mesh Twitch, don't acknowledge this, it's a scam. Close the window. There it goes, it closed on its own. No, so this is different. I think it's different from that type. No, what this is, it pulls up the big thing and it gives you a phone number to call to fix your computer. So it's like, we all know that that's shady. We just Alt F4, right? We just get out of that. We know how to close programs that are a little bit more than persistent. And we know that like computers glitching out on their screen, that's a hardware problem, not a software problem, not a hacking problem. But apparently that got hook, line, and sinker, got the family member. And I feel bad for it, except for the fact that I had to like argue to within an inch of my life to get control of the computer. So they log into the computer and they assure this person that they are legitimately from Microsoft. Because look, there's a Google phone number. And if you go to this website, you can see that I'm legitimate. And if you Google this name, you can see that I'm legitimate. So they're doing shady stuff with other people's identities at that point. They had enough overlapping things to convince this person that they were from Microsoft, which is, you know, that's a big red flag for us. Fake driver pages with phone numbers. No, this wasn't drivers. This was, I believe, you know, the best bet that we have is through Facebook. But so when I got upstairs, what I saw on their computer was a bunch of windows open, a bunch of command line windows open. And the dead giveaway, and the only thing that I can really point to with that amount of time, because like the clock is ticking as soon as you see something like this. I also wasn't totally confident at first that this was in fact a scam. My confidence that Microsoft will never give you a phone number to call them with was shaken from the get-go, and I really should have put my foot down about that, because they will never do that. But what we had is, that is the wrong, oh, that was my found it window. We had a bunch of command prompts, and when I was shown the error, it was basically, it looked like this, but with where's my delete key? Sorry, small keyboard. It was like that, and it was directly on the C prompt. Yeah, just like the IRS, they will send you a letter. They will never call you. No, this wasn't a call. No. You guys have to understand that, like, the susceptibility of this family members, because it told them to call, which is, again, not something Microsoft does, but it's also not something that everybody knows Microsoft won't do, right? Not everybody knows that Microsoft will never have you call them. Never. But in this case, you know, the person was not familiar enough with these sorts of things. Even though throughout my life, this person has taught me to be very careful with credentials and details. And I take that to the grave, that caution. Whew. How are we doing? I don't have any viewers. This is supposed to be a big project today. It would be a lot of fun to solder stuff. We'll gain viewers as my thumbnail turns over to me soldering. Updating, yeah, take your time, Brink, but I would love to see that, because like as soon as you see all those windows open, the clock is ticking. They apparently logged into their bank account with all of this stuff, all the monitoring stuff running. They checked the bank account now and changed all their credentials. Hopefully, you know, more than likely have two-factor authentication on it already, so hopefully that means nothing will happen there, especially if they're changing the passwords. But boy, oh boy, I did not expect that. I'm glad one of us has a checklist in here, because that's exceedingly helpful. Yeah, banks have allowed 2FA for a while. What are you talking about? What are you talking about? That's like a big thing. That's like a big thing. Ooh. This guy's rattled. I'm rattled. I am rattled to the core. How's our print doing? I took a look at it for a minute. Let's get this off of there. God damn. And it's such a common story too nowadays. Those are looking pretty good. I'm printing them in red just because red was loaded. And then maybe I'll give red to Julian when we build these things. So what are we doing today? Aside from this, I'm just gonna hold on. Okay, so I split the recording just because I had to deal with compromise of the Kit Boga style nature in this household, which is a bad idea, or it's a bad thing. It's a bad thing, and you know, it was tough because all the blatant signs of a scam were there, and I had to fight against them. And it's weird how when you're confronted with it, they are vague signs, like they're running a bunch of command prompt stuff. Wait, why does this thing show c:/virus.exe? Wait a minute. And you have to kind of go through that checklist that you know, would normally vet out the scan. And then I had to fight tooth and nail to get them to actually let me. What are you talking about? Everything needs to have 2FA, or at least within reason. And I believe the bank has 2FA on it, so I think we're okay. Just, yeah, I split the recording just because I had to deal with that. What are we working on today? Hi, this is me. Hi, Hollywood Face. Hi, how's it going, everybody? How you doing? I'm not under stress at all. Um, I demand 6-factor authentication. Get the blood sample, put that on there. All right, so listen. I'm the safest. I've got no money. Yeah, if they want to hack me and like inherit some of my debts, that would be awesome. You guys want my debt? Like, go for it. Here you go. Here's the account number. We are building VCOs. I'm excited to finally do this project and stop discussing security because it's stressing me out. Anyway, I would really like to get to work on these LFOs. We are following a design from Hagiwo, who is a YouTuber who makes cheap modular synthesizer stuff. And that's kind of rare in the modular synthesizer realm, right? These modular synth heads are like, oh yeah, it's only $500. And it's like, what? Huh? How much did you say? Whereas Hagiwo is like, hey, I can put a bunch of op amps on something and make a cool filter. And it is $5 and $6 and $10. So Hagiwo, very, very much love them. Absolutely to death. You guys can throw a sub if you're into modular synthesizers over to Hagiwo. Yeah. Why? You're just trying to get a rise out of me. Why? Stupid. What drives the price up is it's rare musical equipment. There's not a whole lot of manufacturing going on in it, and you have people who pour their heart and soul into a custom design. Like there's, for instance, like Mutable Instruments. It's like one person creating all these designs, and they're building them all themselves. And there's just not a lot of. Can I answer the questions, please? I'm literally saying what you guys are typing. I should just let you guys have stream. Why don't you guys just have the stream now? Here are the keys. I already got hacked anyway. Yeah, so anyway, it's one person creating all this software and only selling a certain amount of them and trying to make a living out of that is generally what drives the price up. And oftentimes there are specialty equipment. There is specialty equipment inside of these things, like sourcing a proper, what is that one part where it's the, it's got a special name and it's literally just a photodiode and a lamp. But there's an official name for one, and they're hard to get and they're expensive. Sometimes there is discontinued ASIC hardware in these devices in the modular synthesizer world. In like the guitar pedal world, it's pretty much just, I don't expect to be selling a lot of these, and it took me a lot of time to build, so I'm going to sell them for a big price. And I can get a big price because it's musicians buying them. That's kind of part of it too. So Hagiwo is kind of bucking that trend and sort of setting that back a little bit by saying, look, the RP2040 is $5, so I can build an $8 sampler with one. And I love it. What we've done is we have combined both the Hagiwo designs with mutable instruments. And I'm doing this in a particular way. Where I am incorporating mutable instruments circuit design, because they put everything out there on the internet with just a completely open license, right? They say, you know, actually it's CC by whatever, but the license is basically, yeah, just mention me and give me credit. And that's the license they put on it. So we have taken the elements of that circuit and we have taken that as basically having a circuit design that allows us to use a 3-volt microcontroller to take in and put out the proper signals for modular, for Eurorack instruments. The thing about Eurorack is all of these signals are all compatible with one another, and they are somewhat of a standard nature. You have a 0 to 8 volt spike that can represent a trigger with a certain timing on it. You have 0 to positive and negative, I think 2.5 volt for audio. And then you have, I think it's 0 to 10 volt for 1 volt per VCO. So for any volt per, I literally just showed it up on, you can just Google it. Lazy people. Lazy, you're lazy. So you have standard signals in a Eurorack. You have standard voltages in a Eurorack. You have plus minus 12 volts, and then you have a 5-volt signal, which is pretty much the bastion of all. Like if your op amps are going to be powered off plus minus 12 volts, in all of the old books, it's 15 volts. We've decided on 12 because it's easier. We can put plus 0 to 15 volts into the modular synthesizer, turn it into plus minus 12 volts with a 0-volt reference, and then off of that 0-volt reference, we also have 5 volts. 5 volts will power all of your electronics, including the 3-volt stuff, because you put a voltage regulator in it, and then the plus minus 12 volts will power all of your audio stuff. Typically, some limit themselves to plus 12 volts. I think I've seen one that was only 5 volts, and some will take just only plus 12. It would be fun to be a weirdo and have a 0 to negative 12 volt entirely powered module and somehow work that out. Probably more trouble than it's worth, and nobody would get your joke. But yeah, that's sort of what we have in modular synthesizers. And the fun part is that you can take your whole modular synthesizer apart, put all the panels back wherever you need them, and it's like a little walled-off garden where you get to play around with signals. And if you plug something in wrong, it doesn't fucking explode. However, if you plug something into power wrong, it will fucking explode. And that's what I have to deal with more often than not with my friends, is they jam all that shit in when they're tired and putting their stuff back together in the dark, and then they'll put it in the wrong direction and it'll fucking explode. And then I have to go through an M303 and figure out exactly what all these chips do when the manufacturer of the device has intentionally scraped off a bunch of the values of ASICs. And then I go through a 5-hour stream, and at the very end of the stream, somebody goes, oh, that's this chip. And I'm like, how do you know which chip that is? And it's because they have experience working with these ASICs. I'm a little riled up. Anyway, we spent the time to go through all of the design of these circuits. I can show you some of the files here. Let me open up the actual thing. This is just one of them. There's 2 additions, and the difference between the 2 is 1 additional knob. And I'm worried about whether or not I actually have all the knobs in stock. So what I've done is, in a single-page schematic, I've put down all the stuff that we need in order to connect to the RP2040. And I also found 3D models for all this stuff, but this is basically the circuit. If we're going to go through the circuit, I can give you a rundown of what each individual portion of this does. We have plus minus 12 volts and 5-volt input. It appears we're only using the plus minus 12 volts. The 5-volt input requires a different plug, so generally I don't use it. Some people do. I prefer not to. I'll just leave it to plus minus 12. And in fact, in my rack back there, I can turn on and off the 5 volts just to save a little bit of quiescent power. We have input and output diodes, D1 and D2. These are Schottky diodes. They are designed not to take too much current to flip over into conducting. A Schottky diode will resist lots of reverse voltage, but in forward voltage scenarios, it is very, very malleable. Very switchable, I guess you would call it. It very easily switches over without requiring a lot of voltage behind it in order to flip. Should have a clear acrylic front panel with edge lit. No. No. Oh, I don't have the module on here. No, there's no room for that. There's no room for that. Why am I dealing with weird, inane ideas? I'm not going to answer to that stuff from now on. You guys are not going to get a reply for inane ideas. Okay, so I have an LM1117 voltage regulator. Why do I know that part number? It is one of the most jelly bean voltage regulators out there. The LM1117 comes in a bunch of different flavors. You can get 5 volt, you can get 12 volt, you can get -9. That's actually the LM7805. You can get minus voltages in. I don't know about the 117. I know the 117 does 2.5, 3.5, 5, 9. It does all that stuff, right? No, it just pulls my attention away from what I'm trying to explain to you right now, and it robs all 38 other people here of having a one-run explanation. Anyway, so LM1117, you can get them in different flavors. You got to be careful, because if you order one and you don't look closely, you might get the one that's adjustable. There's an adjustable LM1117. The end of that part number, after like a dash typically, there will be a voltage level on it. So we have an LM1117 in the 3.3 volt flavor. That's why my schematic has the voltage called out on it. So we have our 12 volt and our, well, VNeg should have been minus 12. I don't know. I might have run into a problem putting the minus in there. So we have ground and then we have minus 12. And that's a downward arrow, points down. So VNeg and then ground, of course, I have a propensity to use this ground symbol. It's the one that I like. So that's my ground. Come and take it. So we have capacitors on here that are just pretty much to smooth out the power delivery and to make sure that when we go up to power, things aren't being destroyed by trace lengths and reflections and stuff like that. They basically just smooth out the power delivery so that your device doesn't see power until power has been established for a millisecond. Over here we have a -10 voltage reference. This is a special part, and this is Mutable Instruments Designs. Now, if I can get my head together properly, if I can actually read this stuff, because I just went through a lot of stress just now, and it kind of rattled me earlier. If I can go through the explanation properly, I can tell you exactly what that -10 voltage reference is doing. Analog design, analog device design, analog voltage design, analog design in general is kind of the Wild West. There's a lot of different ways that you can go about solving problems. In this case, there's a very elegant solution that involves a -10 voltage reference, and it saves our microcontroller from being exposed to voltages just running in on it. Because we're in a 10 volt environment, we're in a plus minus, even up to 12 volt environment. I want to make sure that that microcontroller is nowhere near that kind of stuff, because it is the RP2040 is pretty available. The ones that were used in the Mutable Instruments modules, they're like not common anymore. They're not really recommended for new designs. These are like 2014, 2015 designs. And so the microcontroller's gone out of vogue because of the pandemic and supply issues. And there are other microcontrollers to fill its shoes for not as much money, but I had to get them because I had the circuit boards, and so I had to spend like $25 on a single chip, and I blew one up. I'll never live that down. Yeah, anyway, those kinds of things you just kind of have to swallow and continue on with your life as if you were never affected by it. Yeah, they were not cheap. They might have been $14. I think they were 14. I think 25 might be an exaggeration. Yep, because they're not available anymore, and the only ones that are being bought out of necessity. I moved C9, so now I have to save the document again. All right, so what's going on here is you have a capacitor here that's just there to sort of filter out things and smooth it out. It's recommended in the datasheet. 98 out of 100 times when you're looking at a design from an engineer, the engineer is following exactly what's in the datasheet, like to the T. They follow exactly what's in the datasheet. They say, what's the application circuit? And the datasheet goes, well, you could do this with it. And they're like, yeah, that's what I'll do with it. Bye. That's it, right? So that's what that's doing. Well, this is filtering as recommended by the manufacturer, and then R13 is in there for current limiting as recommended by the manufacturer. We'll have to look up what value that R13 is. I don't remember all the values to stuff. I have an MS Paint document that I think has it all in there, where we kind of worked out what parts of the circuit we were taking. So this right here is a -10 voltage reference. How does that play in to the rest of the design? Well, what we're doing here is with that -10 voltage reference, we're taking it into a inverting amplifier circuit. So the inverting amplifier circuit is taking that -10 and it is mixing it with the input signal. So if you have a plus minus signal, and you're inverting that signal, and you apply -10, and then you scale it by 1/3, which is what this resistor is doing, you end up with a signal that goes from -2.5 volts, and I think it's -2.5. It's somewhere around -2.5. It's somewhere between in the middle. But it starts in the middle of from 0 to 3.3. It starts in the middle, somewhere around 2 volts. So when you apply more positive voltage, it'll go down to 0. And when you get to -10 volts, it'll be down at 0. And since the op amp isn't being provided enough voltage, it can't get too far out of spec for 3.3 volts. And when you apply lower and lower voltages, when you get into the -10 volts, it'll supply positive 3.3, and it won't get too far out of that spec because it is only being given 3.3 volts. This thing can only get very close to its rails, the MCP 6002D. So this is our first safety measure, is that the op-amp is unable to provide the microcontroller with a destroying voltage. The second safety measure is all the math that's going into this circuit, making it scale things to the appropriate voltages. Negative volts are just in reference to ground. So if you have your positive 10 volts at ground and you measure from the positive 10 volts ground to the other ground, you will get negative 10 volts. That's just how it works. So anyway, that's what that circuit is. Now C6, what is that doing in there? Well, the capacitor will eventually let frequencies through at extremely high frequencies. So what it's doing is it's providing us with a cutoff for the extremely high frequencies so that the op-amp can remain stable. It doesn't try to work itself out of its own specifications. C5 over here is not actually a capacitor. This is an electrostatic device. And what that's doing is that's making sure that when you touch this cable, you don't blow up your microcontroller. And then with decoupling capacitors doing decoupling stuff. What is this? This is a something or other key filter. And I don't know, I forget what the name is, Schmidt key or something like that. What it is it's a low pass filter. And what this is designed to do is take the pseudo analog signal coming out of the microcontroller and limit some of the weirder frequencies that you'll see on it. It then goes through an op-amp that will then scale it to an output voltage level. And that has some weird stuff going on it, and I think most of that stuff is just stabilization, and I forget exactly what... I saw this circuit in a modular synthesizer forum, and yeah, it's a good circuit. That's all I really know. This is tied like this just to keep the op-amp from getting unstable. And then this is a filter, but it also has a mixing control on it. So you can basically... the input can either be from this part of the circuit or it can be from this potentiometer. The potentiometer is connected between negative 10 and ground because this is the exact same circuit as we just looked at, and that voltage reference is then sliding up and down and affecting how things interact with one another. Typically you'd put R8 and R20 are basically mixing the input voltages. This is scaling it, of course, to the right voltage level so that it matches what's coming out of R4, and then this thing sorts it all out in the end. And then you can change that scale right there, and you don't need this. This thing goes to ground so that when you unplug it, it'll go to a neutral position. And basically what happens inside of a potentiometer is you have a voltage, and you have two opposing voltages, and you have two resistors on there. You can think of a potentiometer as two resistors, like a voltage divider. And so the ratio between the two resistors and the ratio between the total value of the two resistors determines how much current goes through there and how much voltage is sensed on the wiper pin. As the wiper pin goes from end to end, there becomes less resistance to positive voltage, more resistance to negative voltage, or more resistance to negative voltage, less resistance to positive voltage, and it gives you an output voltage. And this is limiting the amount of current so that it can mix properly with this. Buttons are digital. The microcontroller has a mechanism by which you can enable what's called an input pull-up, where it puts a resistor to positive voltage. And so the pin hangs out at that positive voltage. The resistor ensures that very little current is able to flow into that pin. So very little current holds it there. It's got very high resistance, so it's just holding it at that voltage. When you push the button, all of a sudden you're giving it completely unfettered ground. And so all that voltage rushes out to ground, and your pin is ostensibly held at ground with the current leaking through. Switches, same deal with a pull-up resistor. Only this time the combination of the two switches. There's also a neutral position, so if both of the switches see positive power, that's one thing. If one of them sees positive, that's another, and if the other sees positive, that's another again. And that's, I think, LED. LED, it's just, diodes when you get up to a certain voltage. It takes a certain amount of voltage to get through the diode. When you get above that, all of it is turned into current, and all that current flowing through, which can get to very high numbers, is affected by the resistance of the diode itself, the silicon itself, and so the diode will heat up and explode. So you put a current, you put a current limiting resistor in front of it. Microcontroller gets 3 volts. Potentiometers as just pure input controls. Okay, so that's basically the explanation of everything that's going on. The least explained part is this low-pass filter that I don't even understand, but I just put the values in, and that's the beauty of using Mutable Instruments design. But we designed an entire circuit board around this thing, and I ordered them. I ordered them off the internet. Surely the internet is the most trustworthy place. So I made these beautiful little circuit boards, and I made them 109 millimeters, which was a bad idea because that means that I wasn't eligible for the 100 millimeter board service. Yeah, Emily Gillette of, there's an accent mark over that. You spelled it wrong. They designed I've built a bunch of mutable designs at this point, purely from circuit boards. Oh, that was RC car updates that we never got to. Purely from like the whatever. No, you did it on purpose. No, whatever. I know. How do you even type that? It's Emilie Gillette. I don't know how to pronounce anything, by the way. I'm with Iron MP. I don't know what the hell I'm talking about. Iron Imp. But yeah, anyway, Mutables Instruments. I built a couple of the modules, including a marbles, and I thought those were keen designs, and they were in Fusion 360. All the information about them was in Fusion 360. So I was able to copy a couple parts over and give them 3D models, and now I have these beautiful 3D models of parts that I can use in this kind of stuff. Why do you use MCP op amp in one spot? Oh, that's a very good question. The MCP op amp, MCP 6002, MCP 6004, those are 2 and 4 per chip, right? But the thing about the MCP 6002 is it's good at audio frequencies, and it's only 3.3 volts. This is the important part right here. This is the really important part. Only 3.3, only 3.3 angstrom. I mean volts. Only 3.3 volts. Marbles is really good, but the problem is it turned everything that I produce on my rack sound like marching drums. Bum bum ba-da-da-da-da-da-da-dum, bum 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 ba-da-da-da-dum, bum 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 bum. And I'm like, what the hell am I doing? What am I doing with this? I need filters. We could potentially turn the circuit into a filter if I can figure out some coding. It's rail-to-rail-ish, but the point is that the rail is 3.3 volts. You could put in a different op amp in here, but this is just what I learned from Emily Gillette Designs. And then the TL074 is a good op amp, but it is good at being plus minus 12 volts. So this is rail-to-rail 12 volts, and the other one is rail-to-rail 3 volts. This stuff is not that complicated. Our microcontroller will explode if it sees 4 volts. It'll just go, ah, and then that's it. We're dead. We're dead. It's dead. Everybody's dead. So we only give it an op amp that has access to up to 3 volts. And that way, we don't blow anything up. The TL074 doesn't do rail-to-rail. Well, that's probably why most of the signals are plus minus 10. That's why they're generally instead of plus minus 12. If you're going to ask why the difference between the two are and then correct me on that kind of a detail, why are you asking? All right, so the build. This isn't the build. This is the RC car that I built because I got pissed off at the WL Toys kit. I decided to build a pro RC car. This thing was expensive, but I used all the DOS Micro stuff, and I was able to actually model, this is just a brief aside, I was able to actually model all of the electronics in Fusion. I made dummy circuit boards in order to map out the size of everything and build it in this fashion. Oh, this one isn't included. Rack module RC car. That'd be so dumb. I'd be like, here, let's combine expensive hobbies. Yeah, I had a mental breakdown from the WL toys not really matching up to my 3D models, and I decided, like, I need to know what it's like for the like good RC cars. So clearly I bought a Toyota Prius body because that's the only good car. waits for crowd to calm down. Put down the pitchforks. I bought it because it's stupid. I'll get a dumber body for this thing, but so this is the Atom 2SC kit that we worked on last stream, and I managed to get all the electronics to fit in a feat of iterative design that I don't think I'll ever be able to match again in my life. Basically, I put a little 1mm shelf on the edges and left enough room underneath for wires. I didn't do the PCBs, I just built a representation of them in CAD. We have built a motor controller for an RC car before, but the MOSFETs that I used didn't work out. My H-bridge didn't work. It sucks. Big spoiler, big wing, hood scoop. Actually, the hood scoop could really, because this is the front, right? So if I had a hood scoop, it technically would route cool air to the MOSFETs. Only it wouldn't really get under them, which is why I left a lot of big gaps underneath. But yeah, I've got to figure out how to tune this thing, because this thing has 3 differentials in it, and it's a 1/24th RC car, and it is a dart. This thing can go like 70 miles an hour or something. On my second year of electronic engineering, was wondering how I can get started studying and building modular synths and synthesizers in general. I don't have any good book resources. There is the book that I learned the basics of electronics on, and that's from like me as a 14-year-old reading through this Radio Shack manual on how circuits are flowing around. The stuff that I know out of analog is purely on experience. I've had 10 years of experience working for like the FBI as a contractor on bombs in the early 2000s. So I can't recommend doing that either in order to build up experience. I've always been a natural tinker. I've always been going through stuff. It wasn't until I worked with other engineers who explained this stuff in the way that I just explained the circuit to you guys. And I, like, all of a sudden the door opened up and I was like, I understand all of this. I know how this stuff is happening. I know why this is going on. And then I took one step away from the conversation and it was like dial tone. I just dialed, it all left my brain in that very instant. And I've sort of clawed my way back into semi-understanding what's going on in analog. A lot of the stuff is that engineers, while we're supposed to be basically artists using math, they're not quite, it's more like plagiarists using math. Don't tell it, oh, I messed up my, don't tell it, Bomber Guy, about me. All engineers are like this, basically, especially in electrical engineering. You open up the data sheet for the part, you look at the part, you look at the suggested circuit, and you put that into your design. That happens all the time in digital stuff with ASICs and stuff like that. In analog, there are circuit structures that are followed very often, more often than not. And if you're reverse engineering something, you sort of know what those structures look like, write down exactly what the circuit is, and then redo it over and over until you get it. In order to understand analog stuff, I had to basically throw myself into analog stuff. And the thing that really got me there is that I'm really good at soldering. I'm good at building stuff, right? I guess I can say it. Can I say that with full confidence? No, not really. But I guess I'm good at soldering stuff. And the thing about modular synthesizers is there is an open source community around modular synthesizers that release all of the information for their circuits on the internet and allow other people to manufacture the circuit boards. And so in doing that, I'm able to go to a website, find a circuit board for a particular module, buy it for $10, $15, $20, right? And then buy the parts for it, put them all in there, and then gain a little bit of knowledge of the design. And then that's a private part of my body that you guys are not allowed to see. Then I print out the front panels. Getting to where I am takes a little bit of clawing. You got to be adamant about stuff, but building the PCBs from scratch really taught me a little bit about this stuff. I'm still struggling with 2 analog VCOs. The analog VCOs, I don't know why they're not working. I need to poke around with voltage levels on them. I was able to get the mutable instrument stuff working because it was purely a soldering issue, and I was able to observe a couple voltage levels and kind of get to know them and get to know how they're running. This is still very new to me, but my method for learning is by calling on all of the math that I've forgotten in the past. So pure original work is rare, and any discipline, plagiarism, or borrowing knowledge from others is how we make progress. Yeah, there was a whole part of the H-Bomber Guy video, a whole aside was about the different video editors like calling each other and just saying, how did you get that effect? That's such a good effect. And they'll share that information because it's like a, you know, quality is good for the community. But in this case, it's people who design this stuff going, okay, you guys can have this design. Like I'm happy with this design. I like how it works. This is how I did it. Check it out, everybody. Do what you want with it. Just you know, let me know, or give me buy me a beer. So that's essentially what we're operating off of. I just like to make the reference to giant YouTube drama that recently happened. So anyway, I built a couple of these circuit boards. I actually had Seed Studio. I personally built a bunch of these circuit boards. Okay, I had Seed Studio print them out because they have very cheap service. It was about 20 something bucks for 10 of each design. And I bought a lot of them because I figure, well, they're cheap, right? Like the amount of that I paid for all this would be the amount for 5 circuit boards 10 years ago. Today's modern hero. All right. But basically we took Hagiwo's cheap Eurorack design and we modified it with 3.3 volt op amp circuits from Mutable Instruments. And so the hybrid of the two gives us a little bit more circuit safety, probably slightly cleaner audio. I can't really vouch for that, but it is my design now. But I do give them credit. Where did I put their credit? Oh, Hagiwo and Mutable mix up. So I basically give them credit right there. So anyway, this is going to be a generic Eurorack module. We're going to start with the VCO because Hagiwo has code for it, but there's potential for me to take this design and run with it. This is off center and it really bugs me, but I'm never going to fix it. I really should have done the routing via Topor routing, which is where you just go as the crow flies. Yellow PCB, I approve of this color. I didn't think I would. I didn't think I'd like the yellow PCBs, but there's a nice contrast between the base layer and the copper layer. I'm happy with that, actually. That's a good-looking PCB. I should have put like hashes in the ground plane to make it look like a construction. But yeah, that's a nice contrast there. I like that. I approve of this. So I designed these in Fusion 360, and we did some of the stuff on stream. You can find them in the YouTube VOD section. I go through some of the stuff I'm thinking, what I'm thinking of routing where. I did a lot of the very, very finishing work on these on my own, because with a PCB, you need to do the initial design, you need to route your traces, then you go through about, well, if you've ever played Factorio, you would know exactly what this feels like. You go, is this optimized? Is this exactly right? And then eventually you tell yourself, no, it's not, and I'm going to live with it not being right. And that's sort of where we are with these. That's sort of how it works with this kind of circuit. These are routed. They should be functional. I should not have any issue with them. We may have a little bit of trouble sourcing the potentiometers because I think I'm running out. Topor is so dreamy. It's such nonsense. It's crazy. Some of the projects that we found with Topor are some insane designs where they have overlapping components and it only depends on what they put in. And there will be all these like traces and stuff that are just raw. Oh, it's crazy. Having worked a bit for a semiconductor company, any engineer reading this, do not ever use suggested service circuit implementation without reading the datasheet first and the forums, especially for should work first time. Those circuits should be considered unreliable until proven good. And that's one thing that we skipped. In streaming, I have to be a little bit more brash and brazen with what I'm doing. What's up, Gonad? How you doing? The whole first part of the stream that I skipped, I didn't record. Actually, for my files, it's still going to be recorded on YouTube, but is my family computer getting hacked and dealing with that. So hopefully, eventually, Brink GG is going to get me a little checklist of what to look at. But so the Legoland comment about semiconductor companies and their data sheets. Really, you should use a perforated prototyping board, one of these guys. Sorry, a solderless breadboard. Solderless breadboard is wonderful because you can reconfigure stuff to your heart's desire, especially when working with analog circuitry. It's nice to be able to change things up and figure out what component values you like. We skipped this even, considering that Hagiwo and Mutables are good designs as far as we know. So what I did is I skipped that stuff for fun because I started to build the solderless breadboarding version where you solder it together and it's like a semi-permanent board with a bunch of wires all over it. And I said, man, you know what? Nah, I'm just going to do it my own. I'm just going to build a circuit board because they're cheap now. If I kept it under 109 millimeters, it would have been $10 for the PCBs plus like $20 shipping, but still. Yeah, but there's a really good purpose for solderless breadboard, and having the skills to be able to put something on solderless breadboard is really good. If you need a one-off or like a programmer or something like that that's just a microcontroller that's controlling something external, it's really good to be able to just spin up a circuit board in your shop without having to, you know, fire up CAD and do this and that and the other thing. Yeah, bench testing adapter circuits is one of the places it really shines. Did I miss any comments? I think I got everybody. Still not an excuse for machine learning algorithms to be used for image generation. I'm just glad AI is so bad at building circuit boards. That is the generally accepted version of AI, which is just a very complicated plagiarism engine for creating original works that sound like you've made them yourself. They're those algorithms, I guess, are okay at that. Basically, it's seeing whether or not the words it's choosing are flow conversationally well enough, right? And so when you ask them to do stuff with circuits, they're terrible at it. But AI has existed for some time for trace routing. Trace routing on a PCB, that's been an AI thing for a long time. Metric hash loads of if statements. Could you imagine if yandere simulator logic applied to AI, if it's a billion if statements that just have to be run through in sequence? Oh boy. Yeah, they're not legal, math, science, etc. It's just what language in the branching path is more acceptable. I'll choose this. And that's why you get shocking results where they go, I just told it to show me Microsoft and it showed me the devil. But it's like, no, you said photorealistic devil, blah, 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 blah. You put all of this prompt information. And so you have people claiming that they are now prompt engineers. Checklist is in Discord. Oh yeah, I missed it. Thank you, Brink. You're a lifesaver. There was a lot of very high tensions earlier. One of the things that I want to stress before I forget about it, before I repress the memory of somebody else getting hacked, is how difficult prompt engineering is a real profession. Hold on, I gotta look. Oh, that wasn't the Google window. Oh shit. Oh, sorry. Oh man. Anyway, what I was saying earlier is I had somebody who got hacked, and they did the Microsoft virus hack. And what it was is a shady Facebook login, and they logged into Facebook, and it pulled up a window in Edge, and the window in Edge was glitchy, and it told them to call a specific number, and they called the number, and the person on the other line. And by the way, with the glitch, it said, oh, by the way, the phone line is going to be glitchy because your IP has been hacked. So they called the number, and this is exactly like a Kitboga, John. Called the number, and the person on the other line had layers of credentials that were slightly shady in order to prove that they weren't. So they had a Google account, Google phone number, a person's name to look up to see that they're from Microsoft, and they had all this information to prove that they were from Microsoft. And of course, the person on the other side of the line, thick Indian accent, what are you going to do? Bad reception. When I got upstairs, there were several command line prompts having been opened through a remote access program. One of the more common ones, I forget which one it was. The logo was blue, that's all I remember. They probably had a shady link to download it. But I had to then convince this person that they were in fact being hacked, and this person was not from Microsoft. And they'd already gone through all of the very scary. It wasn't TeamViewer. It wasn't LogMe and Hamachi. But anyway, they had already scared this person to the core with what might be being hacked into. They made them log into the bank account, and so they're going through right now and changing everything. All the stuff is being changed, and I hope to death that there isn't any residual software on that computer, because they were running command line prompts. But the command line prompts looked like the following. Look like that. Like, that ain't a message. But the person saw that message come up on a scary looking screen, and they said, oh no, this is real, I am being hacked. And so what they were doing is they were running one of those error scanners, When that error scanner was done, it would have shown thousands of errors, right? And then that would have been used to hack the person, right? To get their information. Yeah, tree and that, yeah, exactly. That was exactly the sort of stuff that I was seeing. The hardest part about it was convincing the other person that there was a problem and identifying that there was a problem. I haven't watched Kitboga in a long time, right? I know what those scams look like. I don't know the specifics of it. And without the specifics of it, I had no point of argument in order to convince this person that they were indeed being hacked and that this person was not legitimately from Microsoft. I had to get them away from the computer, almost physically, in order to get control and tell them, like, don't ever call this number again, hang up, restart the computer immediately, and then take over from there, deleting all of the stuff that they've done. That was scary, and that was very difficult to convince the other person to get off of the computer. So I had to be adamant, and the main thing that I argued was this: that's not legitimate. That's not what an error message looks like. And they were being, you allowed them access to your PC. That's a hack. Nobody will ever allow access to the PC. So I'm a little stressed out right now, guys. We're gonna try to chill out. We're gonna try to chill out and build some circuits. All right. Yeah, multi-factor authentication is very important, but the problem is it's useless if you give somebody else full access to everything. Kit does explain it very well. I'm glad I've watched the Kitboga that I have, because I was familiar with sort of the methodology and how they scare people. But listen, this person in my life, this person has been in my life my whole life, and they have very much brought me up to be suspicious of security credentials and passwords and numbers and phone numbers and social security numbers and logins and stuff. This is why it bothered me so much that you guys fucking guessed my birthday down to the references that I made and got it right. I don't like that. But hardware MFA doesn't help you if somebody is leading you through your bank account login and then telling you that you need to send them. I don't know where the scam was going to be. I don't know where the scam was going to be. Seven-factor authentication. You get an eye print. You get a blood print, glucose level. What else? We're going to have to sort through a lot of hardware to get all this stuff up and built. Let me get all the modular synthesizer parts, and we'll make a little bit of space, and we'll just start soldering stuff. Oh, man, what a day, right? What a day. What a day. I mean, I'm glad I caught it when I did, but I wish I had caught it much earlier. Yeah, I don't know if they would have done the gift card thing. That would have been a big red flag, but, I mean, they were too close to that bank account for my own comfort. Too close. Glucose level authorization. I need like a thimble full of orange juice, and I need to catch it at just the right time. That's actually not a bad idea. When we all came up with monikers to use online, maybe you should just go full second identity. Maybe that's all we can do. My God, would people stop coming to the front door? Keep getting motion detected at the front door. All right, which one are we building first? I'm kind of curious about the chord VCO. Chord VCO is supposed to make 3 tones per voltage that it gets in, and you can choose different chord progressions. I think we should start with a traditional VCO, though. It's less circuitry, and but the problem is it's the one on the black PCB, and I ordered this just so that I could see what it looks like, and the problem with it is pretty self-evident. Let's see if the micro's ready to go. That looks all right. The problem with black PCBs and white PCBs is that they don't get along. No, it's that you can't see the traces on this thing. Where are the traces? You have to use the reflection in order to see the traces. And you say, because there's always the counter argument people in chat that'll go, whatever you just said is wrong, Bother. In fact, I do it this way and I'm right. Well, I mean, like, look at how much easier it is to see where stuff is going. Like, look at how much easier that is. I use Jardiance. With each day's start, By now, as you see. I don't know what just happened there. I think an advertiser got into my throat. Anyway, yeah, being able to see where the traces are is important. I did this just so that we'd have a board that was done this way. You guys are talking about some weird Linux stuff, and it happened to be a drug name. Okay, so laying out the PCB. I mean, I stayed within the rules of Seed Studio. I kept it, you know, within certain edge of the edges of the PCB. The distance I generally left to a metric grid. Curved traces are mainly just a visual thing. They're just there to look good. Gapping things between the front and the back in order to leave room for vias to go through. And then peppering your design with vias, because vias are, since plated through technology exists, they can do billions of vias in a mere matter of, I don't even know. So basically, plated through holes means that you can have pretty much nigh on infinite vias, so they're helpful for stapling your design together. When we build a design like this, we start at the bottom of the board. We start as low as possible, and then we work our way up from there. So large major players like the switches and the audio jacks will absolutely be the last thing on there because they semi-block our ability to get a soldering iron in and out of things. For starters, the first thing that I'm doing is looking for errors in the PCB. Seed Studio is a good process, though. They do a great job. So any of the errors would probably be down to my own design. Like that, what's that via doing? Nope, that via is legit. So stuff like that. You just kind of look around and you see if there's maybe a bottom layer trace that accidentally is on the top layer. A lot of the PCB design software is built to prevent those very common things. One thing about Seed's process is when you get into the smaller sizes of text, things look a little blurry. They're not able to hold on to the sharpness of the fonts at lower sizes. So this is pretty much as small as I should be willing to go with a PCB. I forget what that size is, but whatever that size is, I'm going to be going back and referencing it if I build another one, because you can't really read that text. And also there's a diode marking that should have been moved, or actually might be a resistor marking that should have been moved up here. That's sort of a late game design thing because I added an LED as like the last thing. And so I added a resistor for the LED, adding that, added resistor text, and I wasn't able to get back and check on that. I wonder if I did it on both. Yeah, I did. I did exactly the same error on both PCBs. That's a shame. That's all right though. Look how much easier that one is to see. Good looking boards. This is why I use Seed Studio. With Fusion 360, there's just a pull down menu that'll allow you to run the job and produce the PCB. And you get a lot of detail, you get very small traces, you get a nice thick PCB, and you get generally good quality out of it. They have to put one of their own tracking numbers on there, so they'll just throw that down on your design wherever they feel like. Yeah, there are very many good fab shops. I just use Seed, and I've liked their quality. Yeah, I'm actually really pleased with this shade of yellow. I really like it. I wish they could have done similar with the black, but I guess, I don't know, there's not that much wiggle room in it, right? You would get like gray. They should do a gray PCB surface. That'd be pretty good. Oh, I didn't close these up. These are connected to the outside ground though, so that'll be okay. Did I do the other ones? I did. Okay, so I did get those. Yeah, I should have done both of these in yellow, but I decided that I would try more of the colors. The only one that I haven't done yet is white. So blue, red, green, yellow. Those are the really good ones. The Seed, of course, does not have purple. Matte black is okay. You just can't really see the traces, but it's matte, so that kind of makes up for it. Matte black is more expensive though. All right, so I guess we could build one of these. Now, which one doesn't have the third? I think the sideways one has 3 potentiometers. This one just has 2. Boop, boop. Well, I may have a potentiometer shortage here. The other thing that I would like to check. With Seed, if you keep within 100 by 100 millimeters, that's when they're really worth it. I do like the night one, but it's expensive. I would get everything in the nighttime coating. There's which one is that, Fat? Which producer is that? They do a very fancy looking coating, so the traces are still kind of like silver. It's really cool looking. Or rather, the traces are copper, and then the plated parts are silver. Very cool. That's Osh Park, but it's a little bit more expensive. 200 by 200 bigger. I mean, you can go check prices. It's called Seed Fusion Service. All right, so moment of truth. All of the 3D modeling that I did has led up to this. It fits. All right, good. Whew. I was worried about that. This is a solder tab device that I'm making through hole by having holes big enough for it in the right places, and the model I got was from GrabCAD. So there's a lot of third parties there influencing this. Cool. That'll be awesome. Awesome. Sorry, I just watched the, what was that? The werewolf movie from Red Letter Media. All right, so potentiometers. I'm going to need 2 10Ks on this. This is just the test board, but I would like to actually build it properly. Here's one 10K. I don't have any more of those. That's good. I could use these, but then the whole top half of the circuit board wouldn't be held on. When you use these ones, well, first of all, the holes are different for these. The ones with the plastic knobs, they're not too bad, but it would help to have a standoff at the top of the board if you're going to use those. JL, $2 for 5. Huh. The problem I had with Seed is that they don't let me order from their main store at the same time as a PCB order. It's like a separate service, so they kind of split it into 2 things, which isn't that bad, but it's just something that affects my... I was going to order a couple more RP2040 xiaos? Xiao? I don't know how to say things. All right, so these should be done. I wanted to get these done quickly, but... I'll have to take a look at how long it took me to get the PCBs, because I think it was on the order of a week, but I think it was a little over. They said that they were getting back for the Chinese New Year on the 17th, and I did get the PCBs rather fast. Let me just see what the information on my computer says. Look at that, beautiful. I think it took a couple days to ship. All right, I'll open up my email on this computer over here, as long as you guys are okay with me giving you all my login details. SEED. So my order was placed. Let's see. Order was confirmed on the 20th. Order shipped on the 26th. So that's 6 days already. And then they arrived. Where is this? Oh God, it's going to be hard for me to find. I'm going to have to scroll up through a lot of conversation to find it. This is what I always feared. La 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 la. I think I did a picture of it. I think. So the 20th to the 26th. And then from there, they basically arrived last week. RC cars. It's all RC car stuff because that's what I've been working on to distract myself away from the PCBs. RC car and 3D modeling. What is this guy? A giant baby? He's like a big baby. All he talks about is his RC cars. What a big baby. More scrolling. Oh my God, how long have we been at this? Huh, let's search. PCBs are in Memphis as of 28. So it would have been like the 29th or 30th. So from the 20th to it was about 10 days, 10 to 12 days. Okay, so back to PCBs. Sorry about that. Took me a minute to search through all of my stuff to figure out exactly how long these took to get here. It was on the order of a little over a week. And here are the front panels. I'm going to make 2 of them super duper red and maybe give them to Julian. I should also make some for Dave too, because these are going to be really cheap once I figure out how to make them. Okay, so let's see. I got the switches. I got 1 potentiometer. I think I have another one over here. Let's see if we can find it. This one 10K? What is this one? This one's all messed up. That's 100K and it's a different manufacturer. Okay. What else do we have? I've got some test ones over here that I think I was measuring off of. Oh boy, we haven't done modular synthesizers in a little while, so everything is a little bit buried. A little bit, if you will allow. $100K, that'll do. Pay dirt. 10K and 100K, it all depends on the quiescent current that's running through the potentiometer. At 3v3 going into a microcontroller directly, 100K is not going to make that much of a difference between 100 and 10K. 10K is just going to have more current available, I suppose. But yeah, it's a voltage divider circuit. So as long as the same resistors on either side, which is a potentiometer, it's designed to work the way that it does, it'll be totally fine. Now let's see, this is the design with 2. Which one is the front panel? It's the one with the outlines on it, so that would be here. And I'm going to test fit the potentiometer. These are the things that'll hold us up if they're wrong. So that fits. It's a little tight, but it fits. Amelia Gillette. I wish somebody would figure out the pronunciation of that name so that I can get it right. I appreciate getting the details of somebody's information right when I'm giving them full-on credit for some of the stuff that they have. Whatever design was in their files for the potentiometer, it had different tightnesses. So the pins that anchor it and the pins that are the 3 pot pins moved in by variations on it. And I used one of the tighter ones, so you have to bend the pins a little bit to get them to fit, but it fits the potentiometer and it works pretty well. So didn't know how to do PCB design before I started the project. That's awesome. That's exactly what I say about embarking on different projects, is that it should always scare you just a little bit, because then it's worthy of growing your skill set. And it shouldn't scare you a little bit like as in like ooh to oh style projects. Those are just scary because they are so lackadaisical. So lackadaisical, but they're funny. But anyway, yeah, I need to do more zany projects. We've done a few jokey projects and we've done a lot of hardcore engineering projects, but doing something a little bit zany would be fun. So anyway, I have no more concerns about the actual physical hardware. I know everything else should fit perfectly. I know that that part fits. I know that well, maybe we should test that out. Let's test that one out. Let's see if our sockets fit properly. There shouldn't be any drama around this. Oh my God, it doesn't. No, it fits perfectly. It fits perfectly. So that's sort of one step in the beginning process of doing a PCB. I probably should have ordered fewer of these just in case there was a problem. And if I do find a problem on this PCB, we need to work around it in order to make sure that the problem does not, or to make sure that when we correct it, it's not the only problem there. So when building a first-time PCB, first time you've sent your design out and you get your PCB back, check the major components to make sure that they fit properly. Once that's done, you start as low to the board as possible and work your way up in height, and eventually put the PCB together, identify any problems that you might have, and cut traces and repair traces. Could not find the soldering and PCB cutting video. I thought you said February 28th, but I might, oh yeah, no, that wasn't the, it should be in the VODs for YouTube, and it'll be the one where I say, there will be a bunch of different streams that are me designing the board. I sent these off to Seed Studio, S-E-E-E-D. They have a Fusion PCB service that also has a pull-down menu in Fusion 360. So the one where we're designing the curved board, that's where, no, not the section that says VOD on the thing. I mean sorry, I'm calling it the wrong thing. It's live stream section. There's a tab for live stream. I haven't uploaded anything to do with these on the VODs. If there is information on the VODs that I'm uploading from Twitch, still, I'm not going to get to them for some time because I've still got 216 to go. I apologize about that detail. All right, so we should just start building. Oh, I need to get one of these sockets. Did I have those over here? Yeah, they're right there. Let me get one of those sockets and put it on the table. Listen, the other week, and it is on YouTube, I did a stream where I show the process of uploading and how annoying it is, and finding all of the individual things that happen in a video. If I'm lucky, I can do 3 in a day, and then I'm completely burnt out on it. So the live section of the YouTube channel, Oh Bother VOD, which all the links are all over the place. I don't think I put links below, but there's a command for it. That'll have the streams where I design these circuit boards. Ordering the circuit boards, I showed at the very end of the last design stream. Pull down menu, 2-layer service, run job, you send them that job. Yeah, the fart box will work on soon. We got to do that Node-RED stuff. Node-RED. All right, these pots are acceptable. I don't think I'm going to be able to find any other appropriate potentiometers, but what I have to do is tonight I need to order a bushel of the proper potentiometer. So the next challenge is going to be finding all of our parts, all the surface mount parts. If I were a smart person, and I'm not saying I'm just not, I would have probably gotten together bins full of the parts so that I had everything laying out in front of me. I have the ability to do that, but I haven't done it. So here's all of our big parts. And we get this over here. And we start building. I have new batteries coming in the mail. These are starting to bulge a little bit. All right. So the first thing that I'm going to want to do is probably the 1 or the 10Ks, but I need my notes on this thing. I put together a brilliantly authored MS Paint diagram, MS Paint schematic diagram. So I need to get into the folder where that is, and I'll just do that over here. And we're going to go to Project, Stream, Mod Synth, Mod, Merc Wheel, Mill Mods. Oh, it's just Synth. My naming scheme is not good. X4046 V2. Panel wiring. That's the wrong one. That's an analog one. Never mind. 4046 is something else. RP2040. It's all 2s and 4s. So those are the order files. There's a 3MF. Where is my design file? Is it on the root directory here? Yeah, it looks like we're disorganized. Blinds, CEM, custard. Kinks, panel basics, RP2040 VCOs. I'll not open this for editing, I'll just open this for viewing. So here we have all of our values and all of our chosen values. And these are edited based on what I've already built. And then what are we putting on the LED? The LED, I think I'm going to put a 10K ohm resistor on, just because everything is too bright for Julian. So we'll put a 10K on that. So let's do our 1s and our 10Ks. We'll run through those and get those down on the PCB. Which means I need to find the 1s and the 10Ks. Those I'll need later. Those are all connectors. Useless. I have a specific bin for 1s and 10s. Crystals. Oh, here's our 10V reference. I'm going to actually take that out, put that down on the table. I'll need you later. If I were to be manufacturing these, I would have... you don't necessarily need a stencil to do manufacturing. Your thumb is going to hate you, but you can go through and put dollops of solder on all the components, and I would probably have a couple of them in front of me, and then I would just be able to, you know, bop out each component as I go. Basically being a meat-powered pick-and-place. LEDs, none of the ones I need. Okay. It's a single op amp over there. These are all the op amps. We'll need that later. Where the hell is this? LM117. Adjustable. 3.3 volt. I only have 2. Wait, no, I ordered a bunch. There's a whole thing of them sitting over there. LDO, no. Adjustable regulator, no. Desoldered mist. Coils, trim pots, nope. Okay, let's see. WM8731. I guess we're not using a DAC in this. The DAC is built into the RP2040. Very useful. EPROMs and stuff like that. All right, that goes over there. Where the? I had a bin that just has 1K and 10K. Did I? I must have passed by it. I must have gone right by the MF. Let's see. Weird. You know, I might have moved it to a different bunch of parts. Oh, here they are. Then the first one that I found. I just glossed over it. Okay, 1Ks and 10Ks. So let's get a 10K for the LED. So we're not blasting our retinas out. And we'll have to add the 10K, or we'll have to add the LED to the code at some point. Now I'm using a miniature precision milling vise to hold on to the PCB. I use it because it lifts it off the table a little bit and it gives me sort of that ability to get in with a soldering iron and put my wrist on the table. It's very important for stability. Stability is a quite important thing when you're soldering very tiny things. Move these out of the way. All right, now, since this is 0603, this is obviously not the right size soldering iron tip for the job. Let's get the light in here too. This out of the way. Got a nice collection of parts. We've got a bit of a mess on the desk. I'm in my lane. I'm thriving. Let's get... Well, the choice is... The lineup here is... This is probably going to be the best choice for this size. It's a slightly blunted tip, and that gives it a little bit more surface area. These needle tips are not going to be enough heat on some of these pads, even though I do have pretty aggressive isolation from ground. These would also probably work too, and they would get a lot of heat into the tray or into the pad as soon as possible. As you can see, I've got a bunch of them, but it's a choice between blunted, sharp, sharp, or blunt, or ridiculous. So we're gonna go with this one right here. Boink. Okay. Did I unplug it? Oh, it's plugged in. Oh no, it was unplugged. All right, I need to get thermals working. Ow, that hurt. Boop, boop. There we go. Okay, tip change. Yeah, it's an old IRC command. It's funny that Twitch took some of that old IRC stuff and implemented it. Oh, iron on. There we go. Up to temp. Get solder over here. I got thinner solder specifically for small stuff like this. So we'll see it hopefully benefit us. Oh, but wait a minute. These are 0603, not 0805. I think the ones I have are 0805. We're going to struggle with light levels during this build. Well, I think I can put 0805 on these pads. I think I'm struggling for certain values of 0603s. No, it doesn't show up as an autocomplete. It's just something that IRC's always done. Oh, there's a bubble in my desk right here. Let's move up a little bit. I can't work on top of that bubble. I need to swap out the mat. There we go. I can't believe I messed up the one joke on the whole board by leaving a resistor marking right on top of it. Stupid. Getting comfortable is a big part of soldering. Keeping the tip clean is another big part of soldering. These are things that welders know and painters know. Prep is everything. These boards are clean. They're directly from the factory, so I don't really need to do any cursing. I guess I don't need to do any cleaning. I guess it is more cursed now. Yeah, it looks like the 0603s fit 0805s. These are actually 06s. No, these are 0805s. Looks like it fits it, but it's not happy. It's perfectly placed. I don't think so. Yeah, so I'm just basically making sure that solder flows into it. I don't want to add too much solder. That's borderline too much. Too little is actually the real crime, though, because that'll lead to weird connections. Now I look around for any other 10K ohm resistors. I don't have a bill of materials for this because we kind of took this off the cuff. So anything 10K within the circuits that we're going to build, we're going to put in right now. And then we need to refer the R numbers and the C numbers to our, okay, Salin bandpass filter. That's what it is. So anything 10K. I don't think there's a lot. 1K, 1K, 220. Those are part of the circuit that we're replacing. 200, 100, 33. It's an analog circuit. There's going to be a lot of stuff. This isn't even what we're putting in. No other 10Ks. I'm putting a 1K there. All right, we move on to 1K. Find what? Sorry for what? Oh, I'm sorry. Sorry for what? This we're not using. Under 100. Yeah, okay, so there's no other 10Ks. 10K is just to keep the LED from blasting our retina out. So now we move on to 1Ks, since I have a whole bin full of them. Although I think one of these reams over here is probably the right value. 24.9. Eh. What are these? These are also 24.9, I believe. I'll just leave that over there. Okay. That's over here. And 1K. So there's a bunch of 1Ks. We'll start with the one here, the 1K that's on the -10 voltage reference. That is going to be a reference here to pop, 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 pop. And this is the one with 2 potentiometers, correct. Is there a third one? Correct. This is the wrong one. So we go to the other schematic that I don't have open. Need to open it up. This isn't the chord VCO, I just called it the wrong thing, so the nomenclature is confusing. Loading. Okay. Somewhere in here, we have RRP 2040, just chord VCO. That's the design file. I'm looking for the schematic. That's this right here. Let's close that. Okay, so there, R13. So we're looking for R13, and we can actually highlight it on the PCB with this. I could probably click it in some way and it'll show it, but I could just find it on the board. We can just search for it. Things are moderately logically laid out on this board, and I did it, so I kind of know where things are. So R13 is right there, and that is a 10K. Sorry, 1K. And this is what we're going to be doing all day today. It'll be a nice, easy video for me to cut. Most of it is just me working on stuff. Find part, reference the part, solder it in, move on to the next one. there's a nice little keep out area on these parts. I think they're originally SparkFun resistors, and the little keep out area, actually no, they're not. They're Seed Studio resistors, because the SparkFun resistors, I almost bit my tongue. Actually, I almost bit my tongue just then. The Seed Studio resistors give you this nice keep out area in case you need to install the larger size on them. It just gives you a little radius around the part, and you're like, ooh, you better be careful just in case I only have the size above. Yeah, I'm not doing cuts for each individual thing. Some of the cuts that I do are only a couple minutes long. I've never sneezed and lost a part. You guys should know something about the way that I organize my process and my ergonomics when I'm soldering stuff. Hold on, let me just get this other tab here. So I am sitting bolt upright when I do this stuff. I'm sitting like this. This is literally how I'm sitting in order to do this work. And this work is all the way down on the desk down here. Tweezing too hard and it flies away is solved by having the proper tweezers, and that's these. These have a nice wide front to them. That means that when they grip something, they're less prone to having the two bits of the tweezer do the thing where it's like, bah! Because when you do that, that's when it flings the part away at a billion miles an hour. So these smaller tweezers can do that very easily with parts because they have a singular point of contact, and that these tips can bend very easily. These do not bend in that axis very easily, and they keep their accuracy very, very well. That's why I use them. But yeah, I am bolt upright because the microscope has the OBS feed right there. So I'm looking at my OBS feed. I can see everything that's going into it. I can see all of my commentary stuff that's happening. I can see all my stream updates in case you guys feel like subscribing to my poor ass. All that good stuff. Well, unlose your good tweezers, because I lost mine and I had a backup set. That's what these are. These are the backups. All right, any more 1Ks? Yes, there's plenty of 1Ks in this design. We just don't have the ability to search through values. Look at my tips. Let's see. We are in the weird viewer program. I bought 24.9K resistors, so we're lucky that that one's solved. 4.7, I don't think I'm incorporating in here. Anything 1 kilo ohm. That would mostly be over here on the digital stuff. Well, actually, the potentiometers and analog stuff, they have 1 kilo ohms coming from them. That would be not shown. Those are over here, I guess? No. Yeah, 10K, 1K. So these are 1 kilo ohms going into. I didn't put that capacitor there on that line. I probably should have done that. So that would be the two that are adjacent to is R10 and R5 because they're right adjacent to the potentiometers. The 1K is just there as a current limiter in case something goes funky. I do have a bunch of F-beads, but I don't think they'll be useful in here. I'll have to find those. Did I bring a part over, or is it... I thought I brought a part over. I thought it was... Okay. We're just going to move on. These are unfortunately stuck together with coffee that I spilled on them. It might not be lost. It might still actually be on the board. I just don't see it. Eyebrow tweezers? Yeah, the beauty tweezers are actually really sharp. They're very well made. OctoJ was going to have me send some to him, but it was way too expensive to ship to Canada. So I just bought myself like a kit of them. And I was like, hey, these are good tweezers. I used them to take a tick off of my dog the other day. Hold on, my window's too big and it's blocking the names that I'm seeing in chat. I need to do this and minimize it. Logical thing to do is to start with the ICs and other small parts. No, you start with, start with like the resistors and stuff. The big stuff is fun to solder, but you gotta earn it. I'm never tempted to solder the big stuff first. You size out the big stuff first to make sure that you don't have any game-breaking size issues going on in your circuit. And the 3D model in Fusion 360 really helped me almost eliminate that step. Having the 3D model and having it all up to specifications it's really good. It's really a game changer. Yeah, the satisfaction of soldering the big stuff onto the board, you got to earn it. Sometimes you can buy modular synthesizer kits where they've done all the small stuff first, and I don't agree with the philosophy of that. I think you need to suffer through the surface mount in order to get to the through hole. The only thing that I would advocate about that is that people who aren't as good at soldering can get those kits and then build stuff. Julian's done that on several occasions, and you can get nice, cheap modular synthesizer stuff that way. I think that's good too. I went through a lot of trouble with the mutable instrument circuits where things weren't quite as soldered as they looked like they were, and that was very frustrating. And I don't think a lot of people would be equipped to deal with that level of frustration in their circuits. I contacted people, I contacted YouTubers. Some very nice YouTuber helped me think about some of the stuff that might be going on. A lot of the things about the mutable instrument circuits is that all of the STM32 stuff that can be used to troubleshoot the circuits has been removed from the code. There should be a totally different folder of code where you can troubleshoot the circuit, but nobody else has this problem. I don't think a lot of people have completed their mutable circuits. I don't think a lot of people have put them. How is my first question. My first question is how? How did that flip over? I don't think a lot of people have actually completed them. I'm among the ones who have and have had them perfectly working. And part of getting it working is troubleshooting the individual connections of things. I really should have waited to put the microcontroller in until I tested at the microcontroller pads what the voltages coming in were. I shouldn't have jumped into having the full micro there. That would have been a much better thing for me to do, and it would have saved me from blowing one up. Especially with such a comprehensive circuit and such an expensive micro. Doing things modularly is something that you forget about because you've got this big, awesome task to do where you get to build all this cool stuff. But doing it bit by bit and testing the individual bits can be a very good way to go through a circuit and not get things wrong. We're going to do this all in one fell swoop against my current recommendations because I'm a streamer and it'll be funnier if it doesn't work. So, well, that's essentially Julian's call to action, is to go, hey, why don't I get bothered to just build me a bunch of these circuits? I'm shocked these don't actually have any. Those are the buttons, don't have a 1K on them. So, all right, we got 2 more 1Ks on the board. Let's see what we got. But yet, don't do that. Don't find your local friendly electronics technician and have them build it for you, because that's ridiculous for them. It's a total waste of their time. If you're really lucky, you'll find somebody who will go along with that, but for the most part, it's insulting. It's fuck you. I got other uses of my time, man. You're subtly saying that. Of course, of course. A 1/5 of whiskey would not be worth soldering to me, no. A handle, and we're starting to make a discussion here. What's legal in your side of the state? Yeah, so the switches and the buttons don't get anything. Okay, I'm fine with that. They have a pull-up resistor on the other side. So they're built for that, basically. Saves you a lot of parts. So we don't need 1Ks anywhere else in the design. 5 gallons of cider. I can go to Acme and I can buy 5 gallons of PA-produced cider at $5 a gallon, and I can throw them in a carboy with some champagne yeast that I have sitting in the fridge in the other room, and I can have cider within the week. You gotta do better. 805's per cider bottle. I put the Bosch on the cider. I guess we're down to 1s and 200Ks. We can get into some of the weird ones, I guess. So what do we have here? We have the output circuit. There's some 100Ks. Oh, there's another 1K. R55, but it's not R55. We have to see which one it is. That would be over here, R14. That's going to be way low on the board, so we need to regrip the board. I need to take this, grab it over here. These are 1Ks. I'm going to drop them down. We don't trust them anymore. This one is a... Oh, wait, no, that is a 1K. Come back here, 1Ks. I'm sorry I fought. I didn't mean to yell. Okay, so we need that 1K. That's R14. There he is. I mean, designing the circuit kind of helps you be familiar with where all the functional blocks are. We didn't use like some crazy routing scheme which put parts all over the board. I know, it's like how could you not like building something with your own 2 hands? The sweat of your labor. Your blood, sweat, and tears, all gone into the electronics design. You've earned this. That's like major tombstoning. I need like a simultaneous side view. That would be pretty cool. There was that one view where they had the camera in from a isometric perspective, and then they had like a motor to spin the camera around so you get fly around views of your circuit. That one was kind of cool. The only other way to do it is to do a binocular microscope, and my particular favorite binocular microscope is the Scorpion and the like. It's the stuff from that company. I forget what company it is, but it's called the Scorpion, and it has a lenticular lens. So like the kind of lens where when you look at it at different angles, you're seeing different parts of the image behind it. What that means is you can have different parts of the image reflect differently into different areas. So if you're spinning that mirror, you're getting lenticular projections all around the viewport of that machine, which means if your head is looking into that port and it's moving around a little bit, the optics are still being resolved by the spinning lenticular lens. It's weird stuff. It's really weird stuff, but what it means is that you're looking into this hood. And by the way, these devices have been on Star Trek: The Next Generation and sci-fi's ever since as like, whoa, cool lab equipment, but it's like an actual engineering tool. You look into this thing and you can move your head around a little bit. You don't have to crane your back. You don't have to put your eye up against the little tiny view thing. They show up on eBay a lot. So if you're looking for a personal microscope and you want like a really good one that'll give you stereoscopic view of the stuff we're looking at, and that'll tell you if your chip is like this, that would be something to look into. If I could tolerate more cameras, I could strap a camera to my belly and have a horizontal view of the board, but I don't know. I don't know how much camera equipment I can stomach. I've got a light that's like taking up my personal space right now. Currently deciding if it's more fun to buy a DIY linear high-frequency amp or designing and buying the parts for one. Depends on... That's a tough call. Because if you're getting into RF, you're starting to approach belly cam. You're starting to approach the part where you need to know a little bit more about laying out traces. Certainly learn a lot of cool stuff. It's a lot of detail chasing. Yeah, you can definitely learn a lot. Okay, so there's no more hidden 1Ks or anything like that. We're going to look around for the next part that we're going to install. It'll probably be some weird value resistor. Yeah, RF is a lot of detail and a lot of knowing when to just wing it. IMO. So I can get the 0603 book and we can get some of these values. The value that I have sitting on the table right now is 24.9. And so we're going to use that in a couple different places. Basically, anywhere that we are scaling... Actually, we're scaling inputs with 24.9 over here. But this isn't part of the circuit. Let's see. Yeah, that would be the input there. That's the other 24, 24, 40. There's slight differences in some of the pieces of the design. 39, 39, but then we have 24.9 there. It's only that one resistor, huh? Strange. What about you? 33. Yeah, that's a 1 to 3 ratio. 1 to 3.3. 10 volts to 3.3. So 100K, 3.3K. Magic. The magic. Winging it is my antenna. I mean, if you measure it properly, but you can also get just here. Hold on, I have it right here. RTL-SDR, a amplifier board, so RF amplifier, white noise generator, mini circuits, CPL 13 dB. It is an input-output flow restrictor, basically. So what happens is you hook up your antenna on the J1 input, and the coupled port gets your amplified RF from your RTL-SDR, whatever source you have, and it's whatever transceiver. White noise gets injected into the well, that's the J3 output. I might have the inputs and outputs mixed up. The whole point is you're injecting noise into the system and then reading what comes back out of the antenna, and then that can do antenna tuning for you. So when you tune it properly, you'll get a frequency where all the energy is lost, and then a fraction and a fraction and a fraction and a fraction. There's probably circuits that do this already. I put this together like in the late 2000s, the mid 2010s. I put this together. So there's probably other stuff that does that, but yeah, it's just doing SWR, standing wave ratio, can tune your antenna really well. I'm doing 24.9. What is this? What are you? Nano VNA is a vector network analyzer. Oh shit. 4.7. One of those multi-oscilloscopes did network stuff really well. I'm trying to remember what that was. Here's the 24.9s. Because you could just do standing wave ratio directly from the device. It was like a couple $100, but I decided to get my super duper oscilloscope instead because it's super duper nice to have with the stuff that I do. I don't do that much RF, to be honest. Yeah, there's a whole class of testing tools that are coming out now that are... What, $50? That's almost worth me getting. What type of a tool is it? It's something you plug into USB? If I was doing more RF stuff, I'd be looking at that, but I'm definitely not doing it. I'm not doing any RF. You can't make me. Give me the resistor. Just give me the... You're like the only one of these that goes onto this board. Oh, it's totally... Oh, that's really awesome then. That's super good for the price. Wait, no, not R15. Which R is this? R16. Oh, it's right there. Way colder at the top. I have the window open, and I guess it's finally cooling off. Last night, the folks here, being the age that they are, turned the heat way up and then ran the fireplace at the same time, and the whole house was just super duper warm. Then, on top of it all, my dog does not appreciate pooping in the rain, and it has been raining here for a month. It's been raining here for a month, and the simple answer to why is because I have the RC car fully built and in running order. I made the tray for all the electronics, and I soldered it up, and I got everything together and ready to tune, which means that, of course, it is going to rain here in perpetuity. If you'll excuse me for a moment, I have to see a man about a horse. Grabs wallet, runs away. You gotta let us know what it's like, just because I don't trust. Yeah, I didn't do any of it on stream. I really should have done it on stream. I should have done it on stream. I didn't expect it to go so well and so quickly. And I got the VCO boards, and I really wanted to do those on camera. This is not actually blurry. This is the silk screen quality at this size. But the rest of the RC car project was taking one beam from it. Here, let me just show you that real quick. One single beam from the car and figuring out what the hell the dimensions were. And that required a lot of photocopying, which requires me to kind of do that offline. And so I planned out exactly what that beam looks like. And then I made the beam in Fusion 360, and then I positioned the electronics in the only way that I knew that they would fit. It's unfortunate. I could make this a lot taller, but part of the whole thing about this design of the RC car frame is that it's as low to the ground as possible. So there are a few places where I could have snuck the electronics in. Like here would have been a good place to put the radio vertically. Could have put the radio vertically. The gyroscope has to be horizontal, I think. Otherwise it doesn't, what's the point? The motor controller is rather large. So technically I probably could have put it over the servo and then put the two things like here. There's a little space right there too, but I decided to be kind with myself and just put it up on top. This is a part that's actually for the WL Toys kit, but since it's a standard Mini Z size, I was able to put this big protector up here because the very first test drive, I bonked it and I had one of the ball joints come out. I don't understand. One of the things that I keep bitching about in my Stream Projects channel is these wheels are pretty small, and they're basically made to fit like a car design. They're made to fit a car design so that it looks like a car, but they're kind of small, radius-wise. I don't understand how the millimeter that I get of ground clearance, like that doesn't seem right. Also, wow, that's very toe outy, or whatever it is, cambery. Huh. I want to pull that in just a little bit for stability. But yeah, I haven't been able to do a speed run with this thing yet because it's been raining out. This tray is just based on the beam below it, and all of the wires are held underneath, right-angled port, and then I put a pin header on the motor because it shouldn't be running that many amps. I mean, the amount of copper in that wire is about the same as the amount of copper that's going through that pin header. It's one of those circular pin headers. So there's a bit of tuning that I need to do. I have no idea how to do the ratio of the diffs, the differentials, in order to get them to function properly. I have 3. So turning ability, slipping at high acceleration versus front to rear power bias. I don't know. Things going well and quick in streaming probably don't mix very well considering how distracting the stream is. Yeah, that's another thing. Anyway, yeah, that's the RC car project is, I don't know, it's at an impasse for now until anything else happens and it dries out. But the VCO has been on the table for some time, and then I've got some paperwork type things that I need to get to. I need to make sure I get done because, yeah. But then, as I was saying last night, because it was raining, my puppy dog does not like going outside, and so she doesn't like getting her paws wet, I guess. So we took her on her normal walks, but at one point she heard something really scary and came directly back inside, like with no hesitation. Should we just run up these in value? We're just going to run up these in value. We're going to check out what R18 is, and we'll move up. Let me get my 0603 book. The Tome of Resistors has been summoned. The Grimoire of Resistors. Okay, so what she did last night is she hopped out of the bed, went down into the main big room here, and took 2 shits, and then peed. So last night, 2 o'clock in the morning, I come up from my lair, and I am immediately hit with the scent of dog poop, and the whole house is hot. It was bad. But yeah, I did finish the RC car design last night. That was a big deal. Okay, so we've got a tome full of resistors, and we've got resistor numbers. We can just go from one side of the board to the other. These are fairly unique. There's only like 1 or 2 of each value, so might as well just do it this way. So R18, I'm going to the schematic. Yeah, she shitted and pissed all over everything. It was bad. It was a lot. She was in distress. So R18 is the top of this little Jim Jam right here. And that value is going to be, this is where multi-monitors helps, but I can only use one because I have to show you what's going on. So that's 100K, which should be a fairly easy to find value. 100K. Looks like I bought more. I replenished my stock of 100Ks because I'm a good boy. Use 100Ks a lot because they're used in mixing analog. Yeah, it was obnoxious. I came upstairs to like just dog poo smell permeating the entire floor. The house is not big, so that pretty much tainted all of the air that was contained within the house. I had to open everything up. Plus, it was like 50 degrees last night, Fahrenheit. I was dying. I need to be almost actively cooled at all times. Water cooling. I'm just dumping cooking oil on myself all the time. That's the wrong one. That's the right one. Where did our resistor go? Doing it this way is a little bit slow, where you do value at a time. I could have sworn that I dumped... Oh yeah, it's over here. It takes a bit of time, but if you're building multiple boards, it helps to put all the parts that you need in a place, like in a bin, and figure out exactly how many you need. And that's where the bill of materials really comes in handy, because you can just run down the bill of materials and have it organized by value. And then you go through your value books. You go, all right, this one I need 4, this one I need 6, this one I need 2. And you put them in separate bins, and then you have all the bins to call upon in order to pull the parts, and everything is right there. That's how you do that quickly. But when you're building a one-off prototype, it doesn't apply. So the one-off prototype build happens before the factory build, so you don't waste all the factory parts. I know it's crooked. There's not much I can do about that. If I run it in the oven, it'll fix it, but it's still that value sitting right there. All right, so the next resistor that we see, R11 and 12. $11 and 12, and those are 3.33 or 33.3. 39, okay, 39K. Dude, 39K. And lo and behold, I'm missing a bunch of them from all the other synthesizer builds. We need to figure out effects too, because I don't have effects in my... I don't have many effects. I think I have one. And those are like the appeal of the synthesizers, the effects that you put in. I think this will be able to work as an effect. I just don't know how many RP2040 circuits I can find that are effects with one in, one out. Like, how is the RP2040 at reading audio inputs and manipulating them? I do not know. It would be neat to be able to use, though. All right, 39 going in. And I know these designs are good because I've built a couple of mutable instruments modules, and they use these designs pretty extensively. So we know the theory behind them is perfect. The individual values are just there because of the math that's going on in these. You know, 33K versus 100K, 3.3 volts versus 100 or 10 volts, 100 volts. Yes, it's my 100-volt synthesizer. It's got 12 victims. Boy, what a stressful day. I really hope nothing terrible happens from that hack. The list from Brink will help me set myself assured. I think they didn't get to the part of the hack where they manipulated the person into sending money, but I'm wondering what they were able to get directly off of the computer. A valve-based synth with 200-volt output. All of your transistors are screaming. R9 and R6, giggity. 9 and 6. Oh wait, we need to look at it on this schematic. 18, 14, 16, 9, and 6. So that's our input, direct input. So I'm going to guess that's 133. Don't hesitate to DM on Discord if you find stuff you're concerned about. Can do. It definitely will. Thank you. Thank you, Brink. R9 and R6 are our inputs, and so that's 133, the ones I was talking about. So that means R9 is 100. Well, 33 is right here, which I'm also running out of. So R6 is 33K. Where'd it go? It's over here. I keep putting the resistors in the staging area and thinking I'm dropping them totally elsewhere. Come on, bud. There it goes. Sunny side up. Yoink. There's that one YouTube channel where the guy has like a full pick and place machine. He builds like carnival equipment. Really cool. It's a very old machine though. I would get very annoyed with the old interface on it. But it does this work. And that would be kind of valuable to have. Something that just does this for me. I don't really have circuits that people will buy from me for exorbitant prices that I have to build for them. Because he builds like the controllers that run the like fair rides and stuff. So it'll be like an MP3 player that triggers a certain like solenoid or a gang of solenoids or something like that. And apparently that's like custom built from one person, which is really crazy. But watching him build them, it's so cool. He even has what I've wanted to build, which is an ultraviolet inkwell printer. The inkwell printer with a linear slide beneath it that travels instead of the paper. And you can get ultraviolet activated epoxy printer ink. You know, it'll get heated up and shot out of the print head. And then when it hits ultraviolet, it'll harden. And you can do that and make really professional looking color labels on stuff, which would be super duper useful for the modular synthesizer. All right, 100 kilo ohm, which I got plenty of. Drop another hundo on here. Get that in. The tome of resistor values is just a game changer. It really helps out with this kind of stuff. R3, which one is that? That one goes to the -10 supply. I'll have to figure out which one that is. So this one is the one hundo that I just got. We should get through the R's and the C's pretty quickly. Once we're through the R's and the C's, we've got a bunch more varied stuff to kind of go in. Things get a little bit more exciting. Okay, R3's value is, it might be 200K for R3. Let's check the notes. 200K, I was right. So 200K. 200K, right here. Oh God, I'm missing a bunch. I guess they're used quite often. That's another value that I should probably think about ordering some more of. would be fun to get back into some RF stuff. I used to do a lot of RF stuff. I'm no expert, but I was close. I don't think getting into RF like on a hobby level would be as hardcore as some of the stuff I did, because the stuff I did was severely outdated and potentially illegal to do here. Is this thing? No, it's still on. It's not getting heat down into it. Oh, maybe I did. I just missed it. I didn't see what I was doing. That's on me. Okay, here's 200K coming in. And there it goes. Gone forever. That wasn't a hard flick away. That was a soft flick away. Hoping that means that I'm able to find it on the board itself. It has left the building. All right. Do a couple taps to knock it down. And I don't see it. Is it in any of the vias? Sometimes they can catch parts. Nope. It went up this way. I saw it. I seen it. Nothing. Okay. 200K. Well, the other part that it could hide in is it could get stuck in the vise. I don't see it stuck in the vise. So then that would mean that it's somewhere on the table surface. And the amount of stuff that I see on the table surface is not leading me to believe that the resistors traveled to any of those. Okay, let me see. Sometimes they can really hold on to stuff with static electricity. Holy shit, it's already 4 o'clock. We'll go a little late today because I robbed you guys of most of the stream by sorting out some potentially ruinous financial things. Here it is. That was so stupidly stressful. I'm so mad. I'm also annoyed I didn't go through the rest of the RC car stuff with you guys, because that's an entire stream, but I guess I'm not starving for content. We can go over that some other time, too. Oh, here it is. That should say... Well, 300 is not the value. In this case, it's 30, I think D or something. And that, for some reason, that turns into code for 200K. These are... It's the big pack of miscellaneous resistors in a folder is nice, but you don't get the consistency of having them all for the same company and the same supplier. They're just various markings on everything. I don't like the coded resistors. I'd rather there just be a numerical code that is directly calculable into the right value, which is the number decade marking. It is indeed number decade and not code, because code is what made this stuff so inaccessible in the first place. To be more straightforward with our electrical engineering. It's less alchemy and more just math. R8 and R7. It's definitely the right resistor, I can be assured of that. Just to prove it, let me get the 200Ks out and we'll look at the markings on them. D. Yeah, those the alphanumeric markings on resistors are totally nonsensical. So I have a policy to never buy them. I don't think I've ever accidentally bought them. I think I've bought a bunch of resistors and I like didn't check and they were still the right kind. But yeah, it's more indicative of early surface mount technology, is when they were figuring out, how are we going to code this with the value? Let's make a code and it'll be a standard and let's publish the standard. And then one of the engineers in the background was like, well, you just put the value on it. They're like, what? Why don't we? And then, so from then on, they've all got the appropriate value on them. Because printing, when surface mount became more mainstream, I mean, printing had come along to the point where we were able to get very small markings on stuff. So it just boggles the mind sometimes why they made the decisions they do. Exactly, like 200K, what if the third digit was something like how many zeros it had? Now let's just put 30D. That'll code it up properly. Bro, we could put 4 digits on resistors. Get your head out of your ass. R7 and R8. What? Wait a minute. What did I just install? Oh, that was R3. That's right. Okay. So 7 and 8 are... Wait. Huh? Same thing as 6 and 9. Oh, it's the same circuit. It's a... Okay, yeah, I'm boy, oh boy, do I get confused sometimes. It's the same exact circuit. They're both the inputs. Okay, so we need another 100, another... I should have built these in parallel. Mistakes. I've made mistakes today, and I don't think I'll ever be able to live them down. So R8 is 1 hundo. Again. That's funny. It doesn't look like I've taken any of these 100Ks. Is this like the second or third one? Why are they all there? Why doesn't it look like I've taken any of the 100Ks? Hold on a second. This is concerning. $333. I think that's 01D. That's really weird. I thought, how are these? All the 100Ks have all of the resistors in it. What the hell? Okay, something weird happened just now. I've gone through a portal and I'm no longer a bother. You guys can just deal with that fact for a minute while I get out the multimeter and I settle this. Yeah, it's like the Roy G. Biv banded resistor thing. I had a test on that, and that's the most useless thing ever. I hate it so much, color-coded resistors. I refuse to learn it professionally. Refuse. I will not. Because we've moved on. We don't need that kind of archaic shit. I've got a multimeter at my fingertips. It's like when the math teacher tells you that you're never going to have a calculator. You don't have a calculator with you. What are you talking about? Okay, so those are 39. 32.95. Where did I get these from? Oh, those are 33s. Wait a sec. So R6, R9 is the input from outside. As you can see, the trace just goes right there. So that one should be 100K, and it is. R6 is the feedback resistor, and that should be 33. It's as close as near enough makes a difference. These should be 39s. That's 39.05. Generally, these are precision resistors. 39.05. They should all be, but I guess they're not. R3 should be 200. 199.7. Okay, so I got all the values right. Then why do I have three sleeves of 100K with no resistors missing? This is I'm starting to lose my mind. Because that one is 100K, but I'm not missing one. We looked at all 3 of the sleeves. What is going on? We must have jumped into like a time portal or some shit like that. So R8 is going to be another 100K. That would be you right here. It's funny, that one looks like a different size. That might be an error. Oh, that's a capacitor. Never mind. But R7 and R8 are completely different designs. Look at that. That's a different resistor. How'd you get into my design? Wait a second. Hold on a second. Why can't I right click on you? Hello? I can't right click on it. There we go. Geez, I'd reminded it's CAD program. Component managed 39, 0603 version 1. Version 39, 0603, version 3 and edits. Since when did that update like that? That's weird. So somehow something got swapped. Yeah, version 3. Components. Fuse, inductor, MOSFET, blah, 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 blah. Where is resistor? BGRY. Those are polar capacitors, capacitor, crystal, diode, fuse, inductor, LED, MOSFET, resistor. 0603, and it's got the marking in the middle. Resistor version 1. That does not have a 3D model. 0805. So where's the one with the 3D model? Components managed. Chips, connectors, mechanical, schematic, modules. This is like an old version of it or something. Well, well, well. Those are through holes. Let's manage the library and see what's going on here. Yeah, this is the most annoying part. Go to the latest version on that one. That's the only components that I have. Okay. I don't know what replaced my resistor and why I don't have a 3D model of it in here and what one I used. Let's try to replace this one and just see what comes up. Well, apparently not the right one. I wonder if I used some other resonator, switch momentary, blah, 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 blah. Neat. 448, shift flat, crystal diode, fuse, inductor. Why would it be called anything other than resistor? Switch momentary, transistor, varistor, Zener diode. These are supposed to be pretty simple. These are connectors. What did I use? And did I make the mistake on the other one? Let me look at the 3D model of the other one. Can I please click on my own? What is going on, CAD? Oh, there's a window open in the background. Let's see, actual Chord VCO version 11. .6, they're all there. R8 is in fact, well, it's probably a different R8. These designs are slightly different. Let's go to the other one. This is the one with 3, right? Yeah. This is the more tough one. So Chord VCO, 3D model. And then R8's going to be absent. R8 has a 3D model somehow. Oh God, it's a giant capacitor. What the hell happened here? And it's going to ground, but it's called, oh, they're flipped. C15 and R8 are flipped. Ah, son of a bitch. That's what it is. Ah, flippied them. So before we let that progress any further, I'm going to go to the PCB design, correct it, and so I'll just have it in my files correctly. That's our first error. To flip the board, we hit the F key. Now I can see everything. Yep, flipped them. I didn't see it when I was rearranging stuff. And that's why we vet out all of our issues carefully. I don't think I did it with any of the other ones. We'll find out. All right, so now we have our answer there. We don't know why all my 100Ks are somehow magically replenishing themselves, but we do know that R8 is this one down here. So we will place one of our magically replenishing 100Ks in there. I do not understand. Oh, you know what? Maybe the one that I put into 91K is not 91K. It is, in fact, one hundo. Yeah, that's what it is. There's 3. That's what it is. Here's where the hundos have been coming from. And they have O&D on them. Okay. Self-replenishing resistor books. I know it's a big upgrade. Very big upgrade. I'm super happy about it, actually. I mean, you could probably set up a script and all kinds of automation that would do something like that for you. Where if you... See, this is when I go to sell this PCB or I give the design out to sell, I just leave these swapped and it'll confuse people, and that'll be the magic secret sauce of all the boards. Like, you know, you get grandma's old family recipe and it tastes like shit for some reason. Oops, that fell over. Multimeter, you do not have a lot of space here. We're going to put you down there. You down there and just let your leads swing free in case we need it again. Okay, let's get C15 in, aka R8. It'd be wild to have a setup where you have the actual, like, oh, god damn it. Where did that go? Where did you go? Please, no. I lost it. It's gone. All right, where is it? It's right here. Yeah, they just up and leave if you're not careful. I'm not used to these new tweezers. My old ones would never betray me like that. Actually, they probably have in the past. Probably very conspicuously, too. Man, all that time, I was hoping we would be able to get more of this done today. But, I had to put out fires. All right, so back to the schematic. After we sort that one out. That is a boneheaded mistake too, huh? I can't believe I didn't see the little air wire. So that was R8. R7 is going to be 33K, which is not on this page. 200K is. 200K is coming from R4. So we're going to put R4 in right now because we're in a convenient spot to do it. Yep, that's all the way over there. 200K. And if one of these works, then both of them are likely to work. Need to make more room. We are going to be doing this tomorrow. Wait. Uh-oh. Uh-oh. Which one's... Well, 300D is definitely... That's a 30D, so they're both 200K? Uh-oh. I don't know if we have any other 200Ks going into this design. This will have to be moved to a place where I can... Or wait, is that 10... is it 10D or is it... Nah. I think this might be 100K. Well, only one way to know, and that's the multimeter. Get that back up on the desk. God, I should just permanently install this somewhere. I know a lot of the streamers have desktop multimeters, and I guess I probably can do that. My oscilloscope can also function as a multimeter, so I could actually put the multimeter value up on screen, and it would be nice and pristine. I don't know if it garners turning on an entire oscilloscope though. That's 200K, 1998. That one is also 200K. I think it might have been the resistor that was at the back of the 200Ks. I remember there was a loose one floating around in that stuff. I don't know if there are any other 200 kilo ohm resistors that are going into this though. A handheld multimeter that's as rugged as the Fluke and has the ability to put some kind of a value up on screen would be really nice to have. Because then I could put the screen somewhere weird and just look at it the way that I look at you guys. 200K is going to be R4, so it's right here. Get off. Get off, please. There. Oh yeah. No, that's just physics. Yeah. Actually, there might be a physics explanation for that, to be honest. You know, because maybe the resistor substrate is heavier than the ceramic, and it causes it to fall on its face. Like toast taped to a cat. The problem is if I don't heat it up enough, the resistor just kind of slides on that smooth surface, and then it lifts itself up in one direction, and I don't see it because I'm looking directly down upon everything. We could do a more isometric view, but I think it would break my brain. I think my brain would be broken. I should have done the yellow one first. All right, let's see here. Are there any other 200 kilo ohm resistors in the design? I really don't think so, because none of the other function blocks are quite suited. 39, 39, 24, 100, 10, 1, 1K. Those are 220, but that's not what we're using. Those parts of the design are gone. 200, 133, 1. No 200s there, and that's not even part of our circuit. 4.7. So there are not. So what I'm going to do is I'm going to go to the other design, and I'm just going to put that resistor in there. Just save myself having to go get something. Which one's y'all's the 200? R3. That's so much nicer to look at. It's so much easier to see. There's R3, all the way down there. So I'm just going to throw it up on one pad and leave it for later. God, it's like day mode. Let's see here. Come on, buddy. There's a little variation between these and my regular ones, and my regular ones sit down on the PCB a little bit nicer. So I'm having, that's why I'm flinging so many parts. Sure, you can stay just like that. It doesn't matter. It doesn't need to be soldered down right now. I will get to it when we get to this board. Okay, so R7. I need to go back to the right schematic. Make sure I have the right design. We're doing 2 designs simultaneously, so it's very confusing. R7 is 33K. Go back to the 33s and grab one of the very last, one of the very last remaining. I have a couple more, but... and dump. That dumped itself. Nice. All right, 33K goes in here. Where is that? It's right there. Rearrange so that I'm a little comfortable. Knock this shit out. Bam. Oh, no, stick into the tweezers. Tweezers might be a little bit magnetic, or, well, we haven't used a lot of flux, so I think it's magnetic tweezers mainly. Okay, get the other side. Where'd it go? Oh, it's way over here. No. What was it? It was R7? No. Yeah, it was R7. Okay, sorry. I completely lost my place. And the iron turned off? No, the iron's still on. Iron's still on. There it goes. That might be the last resistor. It is. I think we got them all. Hey, we did resistors, everybody. U3 is going to be the voltage regulator, the voltage reference, and it is confusingly in a transistor package. So what we do is we flip this thing onto our board and solder one of the pins just to anchor it down, and then get the other 2. We should do capacitors now, but we'll do that tomorrow. I need to go put out some fires. And Brink has been super duper duper accommodating by sending me a little checklist of things so that I can make sure that my folks don't get fucked. I can't believe they got Kit Bogan. It's so ridiculous. I guess they've just never seen that particular hack, and it's possible that the Facebook account needs to be sanitized now. Boy, that's going to be the tea around the neighborhood for quite a bit, huh? Oh, they got hacked. They got hacked. Oh no. Everybody's going to spill this tea all over the place, man. Come on. There we go. Is it flat? It is flat. All right, cool. Off the toast, I'm losing tea. Got to make sure that these pins are properly soldered. Sometimes it takes a little bit to get heat in, especially if you've connected it to a ground. Those grounds will wick away your heat and cause the solder to form a cold joint, and it is very possible that you would be chasing down the cold joint instead of actually doing effective troubleshooting. Listen, it could have been a lot worse if it got into fruition if I decided to ignore all of the hullabaloo that's going on, because when I'm broadcasting, I am broadcasting. I am not here for IT support. But upon the initial hearing of our IP got hacked, the eyebrow went up, and I guess it was then, yeah. Plenty of people lost a lot of money, and that's a big concern because my mother does a lot of financial stuff. I didn't say who got hacked. You didn't hear that. Let's put the big voltage regulator in, because it'll be a fun thing to do at the end here. And then I will let you guys disperse upon Twitch and figure out where you want to go, because I need to go still put out some smoldering fires. It'll just get this voltage regulator chip off of my desk as well, so it won't get lost. And I promise you I will not work on this between streams if you guys promise that you will not complain about the pacing of things. Presumably tomorrow we'll be able to do a lot more because I'll have time. Might even be in for an earlier start just because of what happened today. I really messed that one up. Probably shouldn't do the big tab first because the big tab connects to the entire body of the regulator. Promise to complain. You didn't get that band hammer out. RYG, party like it's current year. I don't... What are we agreeing on? Is it still 2023? I think it is. Didn't we skip the pandemic year? But then that became like 2 years. So I don't know which one we're on. So whichever year you feel like it being, we could party like it is. Oh, one thing that I really need to figure out is microscope lensing for a thermal webcam, because I have a second thermal webcam. I have another one. We've had it for so long that it's gone bad. And I would really love to have a thermal microscope, you know, lens that out so that it's, this thing turned off. Lens that out so that it's just like this, just like the microscope view. So my hand's view would be in the right sort of, resolution. And then this would also be in a usable resolution. So we could see the heat wicking from thing to thing on the PCB itself at this scale. Problem is, the types of optics required for microscopy and the type of optics that pass long wave infrared are quite expensive. Especially if I try to do it at the distance that I currently have. It'd be cool if it was something that went on the regular microscope and had the sort of the same pinhole ability. Can't have everything though. You can have most things, just not everything. Bada bing. All right, that's the voltage. Those are kind of annoying, and I did it wrong. You probably should solder one of these two peripheral pins, because this center one connects to this output, I think. Maybe not in this one. It might be one of the sides that connects to the thing. They sometimes do stuff a little weird. But anyway, doing the ones that aren't like big connections first, that'll hold the thing down, and then doing the big guy nice and slow. That is all resistors and capacitors, sorry, all resistors for the board. We need to do caps tomorrow, and then we can do chips, and then we can do the peripheral stuff, and then we can do the RP2040, and then we can do a little dance because we'll have been done. Some of those caps are also going to be protection caps, but today has been nuts. You know, you tried so hard and you used the slang. Congratulations. Thank you. Okay, so anywho, I am going to stop for today. I'm going to go put out fires. I'm going to go walk the dog. I'm going to go eat food. I am then going to go onto Discord, and then I'm going to hit my head on the desk. Maybe I will go buy liquor tonight, but I'm on a good streak currently, so maybe I'll just ride that for a little bit longer. I might go out though, but I need to do the IT stuff first and then walk the dog. So keep up the streak. I know I need to. It'll be much better for me. So yeah, we're gonna work on this VCO more tomorrow. Unfortunately, just doing the resistors took all day due to external circumstances. I just cut out to keep at it. Yeah, maybe. Say hello to Willow for chat. She reads the room really well. When we were arguing about stopping this obnoxious scam, she was running around like she was in trouble. So I feel bad, and I'm going to go give her a big smoocho to make up for it. But first I need to do, as soon as possible, I need to do that checklist. I'm going to mute this. Is that muted? Okay. Who are these? Oh, Cassidy's on. Cassidy's on. She's got 121 views. This is a friend of mine from college who is now more popular than I am. Damn it. Or no, Cassidy's, wait, that's different. That's game development. Okay, I thought it was somebody else. Never mind. That's not who I thought it was. Cassidy is doing game development. You guys feel like checking it out. It's one of the Knowledge Fellowship people that like Nicandria and people like that sort of filter into my Twitch every now and then. Pretty cool, like Mr. Horologist and the paleontologizing. Oh, Robert is doing Hoi 4. That's going to be an 11-year stream. No, I'm not going to. You guys can figure it out if you want to. I need to go get my goofy ass upstairs and sanitize a computer. I will catch you guys later. Thank you for joining me in spite of all the weirdness of today. Tomorrow we will be doing soldering for the day. I would like to get to that yellow PCB because it looks better on camera, but we need to make sure that, you know, our VCOs can function first. We got to load it up with Hagiwo's code. I'm looking forward to that. So we'll do that ASAP. I will be here almost 24 hours from now. We can get the actual number here. 20 hours, 4 minutes, and 4 seconds. You can expect me to be starting up again. I will catch you guys later. Have a good one. And remember to always give out your IP address to anyone who asks for it, because it's just good manners.